ले।
होल्ड इट फॉर्म ना
बस सिंक में
क्लाउड अरे हाँ ये ना ये अपने आप
ये वहीं रख दे, बस मैं घेर दूंगी अपने आप।
Good evening, Gaurav sir.
Yeah, hi. A very good evening to all.
Sir, we wait for 2-3 minutes until all the participants will join, and then we start this today's session.
Yeah, sure, sure.
Okay, sir. अच्छा बोल रहा हूँ.
Shall we start? Means Dr. Sushma.
Yes, sir. Yes.
Okay.
Uh, just a minute, sir.
Mhm.
On behalf of organizing committee, I welcome all the participants and our expert for today's session, Dr. Gaurav Sinha, sir. Sir is a senior process engineer professional with 23 plus years of experience across offshore upstream facilities, LNG refineries, petrochemicals, and large scale field and detailed engineering projects. He has held leadership roles such as technical advisor, principal process engineer, and field leader with strong expertise in process design, commissioning, and startup, brownfield modifications, and interface engineering. His core strengths include uh, MEG systems, refinery revamps, seawater treatment, utilities, flare and relief system, dynamic simulation, and process safety studies. He has worked extensively with major clients such as ExxonMobil, Shell, Petron, and Worley, and has been recognized with an Excellence Award from Worley based on ExxonMobil's recommendations for capital efficient design optimization. Mr. Gaurav Sinha is proficient in leading process simulation tools, vendor and bid evaluations, and cross functional team coordination with project experience spanning India, Singapore, Australia, China, and the Middle East. Now, I request Sir to kindly proceed with today's session. Welcome, Sir.
Yeah, hi, Dr. Sushma. So first of all, is my voice audible,
Yes, Sir.
loud and clear? Okay, great. Let me start sharing screen. Before that, select a tab to share. Okay. Tell me which screen are you able to see, please?
Sir, the title screen.
Okay, perfect. So, okay. So good evening, all. I believe everyone is from India time zone. So, good evening to all. If anybody else is joining, thank you for your time. I mean, it will be. I'll try to make this 1.5 hour session as painless as possible. I'll try to walk you through some of the journey which I had. One of the things I would like to say, mention to Dr. Sushma is that do not call me sir and do not call me doctor. Officially, I'm just a chemical engineer, bachelor's of engineering. So that's the only my designation. That's my qualification. I wanted to do something more, but I mean, that is something probably at some point I'll try to add on my certificates. Having said that, sir concept is something which I always say that try to avoid this thing. There is no designation of sir in anything with when we are in the professional world. Either you are known by what you are. That is what I believe in. So this is my humble request. If we can follow among our peers, among our younger generation as well, it helps us. I mean, this is what I felt to my when I was relatively young, to my head of department, I used to call him by name. So just a small request. Coming to this slide. So when before I go into the slide, I'll try to quickly mention something here. One of my college batchmates, Mr. Ghanshyam, he's the one who recommended me to give this presentation something in the month of March 2025. He put up this request. Unfortunately, because of a heart attack, a heart failure, he is no more. He was only 46 years of age when he passed away this year only. So, but I would still like to honor the fact that he had requested me for this particular presentation. So I'll try to make the best of this journey and remembering him. Quickly, I'll come to the presentation itself. Okay, and if I start, just help me, Dr. Sushma, to confirm whether you can see the full screen. Okay.
Yes, sir. It is visible.
Okay, so the topic I was given is emerging trends and research frontiers in chemical engineering for green and sustainable future. This is a pretty interesting topic because I belong to the oil and gas industry. That's my entire experience, which I'll come in the next slide. And this has been the talk of the town, talk of the world, that whenever we go to any place, to any conventions, or if we talk about any major meetings, we always say that, are we ready for the transition from typical fossil fuel energy based system to renewables and green energy? And I was also given a topic to add on this one, was something on the simulation. So like I said, I'll try to make it simple going forward, but this is the topic which is pretty much relevant with respect to current scheme of things. So this is the icebreaker slide. Let's connect. So I believe, like many of the people who are attending out there are pretty experienced doctors, they are scientists, they're in the education system as well, with key roles and a key responsibility to give the right guidance to the younger generation, coming to the fact that some of them are doing MTech or even PhD pursuing. And so yeah, I mean, my humble hello to all of you. It's great to connect with you. At my end, I completed my bachelor's of engineering in year 2001. 1 year I was kind of looking for jobs, trying to understand how the thing is. I was just out of the college. There were a lot of aspirations in me. I One thing I wanted to do is I wanted to see actually a live plant. At that point of time, we had read so much of engineering, so much about this thing in our bachelor's, and I wanted to see a live plant, and I wanted to work in the industry. I did not know whether the opportunities will come my way or not. So that year was also a recession year, 2001. So my first actually job started somewhere in 2002 and 3, when I joined L&T Chiyoda. This is also located in, coincidentally, it is in Baroda. If people are aware that, so I believe that this presentation is conducted on behalf of Vidyapith University, Vidyaput College. I mean, and that's also located in Gujarat. So it's like a full circle. Life is a full circle. So I started in L&T Chiyoda, worked on certain petroleum, means basically refinery projects. Those days, Euro 4 requirement on the vehicles was gearing up. For that, for meeting the Euro 4, Euro 5 requirements, those days, many of the existing refineries like IOCL Mathura, and then there was MSQ, then there was MRPL, which is Mangalore Refinery. All these were upgrading their systems with UOP technologies to get the on-spec petrol, on-spec diesel, the octane numbers being the same, but then the requirement for NOx and SOx release was getting more and more stringent. And now we are going for Euro 6 and eventually for Euro 7 when coming 2025. So the thing is moving on the petroleum sector. It's we say that not much has changed in terms of petroleum refinery. The concepts have not changed, true, but there is a lot of industrial innovations, industrial technology which has come up. Okay, so yeah, so which has come up. So what I was mentioning is that so my journey has been from L&T Chiyoda, then I worked in Reliance Jamnagar refinery, that is also Gujarat, for next 2 years in L&T Chiyoda. That was purely design. Jamnagar refinery allowed me to physically see the plant and work on projects which are the live kind of projects. And then they were going for a expansion of the entire refinery, the full scale, like duplication of whatever is existing. They were doubling up the capacity, they were copying the entire plant design and making another one, but making sure the integration happens nicely. And in this 4 years of experience and so on and so forth until today, means where I came to Singapore in 2007 February, and from 2007 February until 2025 January I was in Singapore. I worked in Jacobs Engineering. I worked in Worley. I worked in Cameroon Schlumberger, which is like offshore projects. Offshore means the oil and gas platforms. I even had a small stint with the pharmaceutical industry, about 3 to 4 months, but that was also an eye opener, something I will later express over in the next few slides. And I will quickly move on to the topics, and just bear with me. I might be too fast, too slow. Just cut me out, and you can post your questions in between. I know that typically the questions are supposed to be at the end, but I would encourage people to type it on, because I'll be moving across certain topics in the 1.5 hours as swiftly as possible. So sustainability, what does it mean? It is the same concept, just the bottle is new. The responsibility of the project to ensure that the project life cycle is ensured. Now, if you see, going back somewhere in 2004 or 5, people used to say, go for a new plant, make sure it works for next 30 years. So we are designing everything for the next 30 years. Yes, and make sure everything is optimized. So optimized means you don't waste energy, you don't waste power. You make sure that things like exchanger design is optimized. If there is a heat integration which can be done, it should be done. Recycle should be minimized. So the same thing is slowly catching up in more and more jargons, and it is being from qualitative, we are moving to a quantitative approach. By having said that, like, try to minimize 5% of losses, etc. Anyway, I'll come to that also. So now, sustainability, what does it mean in simple terms? Sustainability encompasses responsibilities not limited to economic sustainability. So economic sustainability means whatever we design, say it needs to run for 30 years of life cycle. Environmental responsibility. So last time the Euro 4 norms were low. Now, if you are saying the NOx emissions from petrol, diesel, now it is going for 60 to 80 mg per meter cube. So basically, this is there is a typo here. And then basically 60 to 80 mg per meter. Then PM, the particulate matter, is also getting more and more stringent. Recycle and reuse as practically as possible. This was always there, but now we are given a at every stage we are being asked in the new projects that recycle and reuse should be done. Carbon footprint reduction. See, this is going interesting, because this is where there was a drive even those days. We were talking about not flaring too much. So if we are having a full-fledged refinery, if we are having a full-fledged offshore plant or any other plant, then these will have emissions. Like your power plant, they have got their emissions. You have a flare stack, they are having emissions. If there is some incineration happening out there, there is emissions. So this all is adding to the greenhouse gases. So we are talking about the carbon footprint reduction. Then the new thing which has come up more like a term is global warming potential. We had always identified CO2 as the major global warming component, but over the time it was realized that we are also, although CO2 is the major bulk which is emitted to the atmosphere, but there are other gases as well. Even in small quantities, they are much more potent compared to CO2. So that will also come in another of the flights, but basically the concept is carbon footprint has to be reduced. Now, then there is a social responsibility. Social responsibility becomes pretty interesting, because what we say is that whatever we are designing, it should not hinder the future of the coming generation. We have a social responsibility, so to speak. We have to provide something which can sustain socially as well. Eventually, we have to make sure that the thing does not affect the future generation. Then comes the energy trilemma. So we have typically, you may have in the last 5 days, I'm sure people have given so many presentations. This word may or may not have come across this energy trilemma. So we are talking about always dilemma. Dilemma means like to go for this option or that option. Both are equally good or equally bad. So here we are having in a trilemma. We want to achieve three things simultaneously: energy security, energy equity, and environmental sustainability. Now, what is energy security? If energy security means we have a primary energy supply from domestic and external sources, reliability of energy infrastructure, and ability of energy providers to meet current and future demand. So what we want to first secure that we are having enough we are secured. Basically, we are having secured means we have secured the sources of energy. Then energy equity. So energy equity means for from every poor person to a rich person, everyone should be able to afford it. So energy equity wise, a country should be able to meet the energy equity. Everyone should be able to afford energy. And the last one is the difficult one. We want it to be affordable. At the same time, we want it to be it to have a environmental sustainability. So this three is a very easy to define triangle, but to achieve this, there is a lot of effort which is going on, and it will continue to go on going forward. Okay, to give you a quick understanding, if you see here, this is the overall performance. Overall performance means inclusive of energy. So all the energy trilemma points up here, if you see, the top 25% is orange in color. Unfortunately, India currently does not fall into the orange category. Means energy performance means affordability, security, and um, environmental sustainability all are being taken care. So we fall somewhere in the 50 to 75%, not top 25%. It's something has to be worked upon. If you see the other countries which are having a problem, is Mongolia somewhere in the eastern part, Thailand, etc. Then there is a lot of problems up there, down there in the African continent, and somewhere in the Brazil area. So over here, so Brazil, Argentina, that's there. Now, again, if we talk about the energy security, which is the first criteria, what we said, energy security means we have uh, effective management of primary energy, reliability of energy infrastructure, ability of energy providers to meet current and future demand. So lot of availability is there. So energy security wise, this is the good part. India is having a decent means it is in the better table performance, top 50 at least percent, which is not too bad for such a big economy, such a big population. Energy equity, again, this is where we are kind of struggling. Not everyone can afford it. A person who comes from an urban background and from a relatively good economic background, he is able to afford the air conditioning in his house. The other guy, even if he does put up an air conditioner on a continuous basis, the budget and the bill is going to kill him. I'm just giving an example. So it's not equity. Energy equity is still a long way to go. Environmental sustainability, is somewhere we have a long way to go. We have a lot of plans in the government. I know that there are a lot of plans currently going on. The thing is, plans to the materialization state, it's still, the process is there, it's going. And this D category does not say we are not, we are the worst. It means that there is a lot of potential that we will be improving in the next few years. I do not have the full idea of what all are going on, but from anybody in our industry, I have heard within India, we are going good in this one. It's a difficult task, but there are a lot of plans in place. Renewable technologies, I just go through the names because nothing which you have never heard of this before. Wind, solar, geothermal, wave, tidal, biomass, anaerobic digestion, hydroelectric, hydrogen carbon capture, are some of the technologies which we are always talking about. Heat and heat pumps, I will not discuss up here. Nuclear also is something which we still have sometime a long way to go. Synthetic fuels, yes, it is going on. In fact, I will touch upon this topic of synthetic fuels, not in a slide, but separately. Okay. EVs, yes, we are going for many electric vehicles. If you see today on the roads, we have Tata cars, and there are all other brands are there. They always talk about the green board cars. They are there. Hydrogen batteries, yes, there are certain projects in place. We are getting there, but it has a long way to go. And I'll come to the reason why it has a long way to go. Hydrogen was a big thing. It still is a big thing, just that the technological breakthrough is ongoing. Gravity, I'll not call this of much consequence. Environmental concerns. Now, whenever we talk about the wind technology, we think that wind technology is excellent. So first of all, India does not have a sustainable wind farm kind of environment. Even if you go to onshore or offshore, not everywhere you can get a consistent wind. It is most sustainable if you see the places where across the world where the wind technologies or the wind farms have been in place is somewhere in the Sweden and basically the northern side of Europe. And then there are certain wind farms which have been made. The largest one, the wind farms are there in China, in a desert. Interestingly, the China one is not being currently used. They have made it, it's there, it's lying there, it's not currently used. It is capable of more than 3000 megawatts, but it is not being used because they're still on coal as of today. So it's they are like technology ready. At one point, for example, in our television, right, there used to be something called LED ready or Android ready. So these countries over there are currently like technologically ready, but since they have got a cheaper source of energy, this is still a long way to go. Now, wind technology has certain other concerns. Means, see, these terminologies are more taken on a like a universal level. So we have PETA, they have avian mortality, bat mortality. So something gets so certain means if this habitat of birds is there over there, then the breeding grounds are affected. Visual impact is there. I'll not go in these points. I'll just go to the consenting and permitting. We need a consenting permitting issues. We have carbon emissions. We have life cycle assessment. So that is all. We have a lot to consider. So when we are planning to shift to renewables is not what I have been directly involved in the industry, but I'll try to touch upon this subject in a faster way. But it is still important when we are going to discuss and compare with the oil and gas industry and what it is doing over there. So eventually my subject will move from going from renewable to what we are doing today in the industry. So hydrogen cells, wind, solar farm, water waves, as we said, these are some of the key ones. You will see today in many of the small villages, the government is giving subsidy. They are giving this thing, and they're giving incentives to go for the solar lights and everything. And there are a lot of incentives by government that they are producing. Wind is still a long way to go. Hydrogen cells, long way to go. It's coming. Water and waves, we are lesser involved in that one. Wind technology, the challenges. So if you will see here, I would like to quickly come on a couple of points here. Wind. So basically, if the wind to give a certain power, there is a minimum wind speed required. So the typical threshold is something like 12 meter per second is the wind velocity. Then we can think about generating a decent amount of power. If the same wind speed drops from 12 all the way to 7, if you see the power almost drops 1/3. So basically it depends on how good and how consistent the wind is out there. So that is while that is a advantage and a disadvantage as well. And also beyond the certain speed, how much ever we try, it is still going to give a power of say 2000 kilowatt for a 2 or a 2 megawatt turbine is what we are trying to achieve. There is another interesting part that the way the wind technology works is, unlike the typical power plant, they do not produce AC current. They have to first convert it into DC current. From DC current, this DC current is easy to transport to the shore, and then it was converted from DC to AC. So this is something which is part and parcel, which comes with the technology. Like you said, needs consistent wind. Upon wind speed exceedance, the fan trips. Yeah, and if the speed goes beyond, so suppose there is a typhoon, suppose there is a storm, and if the speed goes high, this entire system, it trips. So trips means then somebody has to have an alternate source of power. So first is consistent power, and then this other problem is this, that if it trips, then also you are not having the availability. Coal is cheaper on any given day. Anyway, hydropower technologies. See, you may think that why even I have put up this slide, hydropower technology and challenges. See, the thing is, if you see the largest dam in the world are Three Gorges Dam and Hoover Dam. Hoover Dam is in US, Three Gorges is in China. They are all producing more than 2000 megawatt of power. One of the things I would like to mention up here is that they are having a head. When you look at the dams, there we are talking about like 50 to 100-meter head of. Sushma ji, I'm still audible, right? There are a few blips I'm handling. Hello.
Yes, sir.
Yeah, you just let me know if anything. I'm double
Yeah,
checking.
sure.
Yeah. Okay. So going back to the hydropower technology challenges. So basically, right, the thing is that Hoover Dam requires a very big head of liquid. So if you see from this point to this point, we are talking about at least like 30 to 100 meters. But 30 to 100 meters are not always feasible. And you will say, where will I find that? On a day-to-day basis in some remote villages and some. So that is where the micro hydro comes in picture. And micro hydro, by means of its design itself, as low as 2 meters. 2 meters is like almost like the tallest person you have ever met, 1.6 or 1.8 meter, I would say. So that guy, the height of that, if you get like 3 to 5 meters with this kind of design, with a rugged design over here, you will be able to generate up to 5 kilowatt, and 5 kilowatt can lighten up to more than like 10 houses. Okay, so why I'm saying is that hydropower technology, there are developments which are happening today, uh, as small as a micro hydro. If you Google it, and you can find how it works. But basically these things are coming up, and these, if you have the only thing you need is a consistent source of water. See, even if the water source should be there, then you are getting this thing. So I wanted to mention this hydropower technology as one. Tidal energy is still there, mostly outside India. I do not know. If you can help me to know in India, just please let me know. That's another thing, but it is happening. Okay, I would like to mention one more thing. Carbon tax. Carbon tax, I try to compare like 4 countries: Singapore, where I had stayed, Canada, Europe, India. So if you see in 2025, the carbon tax is $18.5 per ton. By 2030, Singapore is going to make this $80 per ton, which means that if a industry is getting set up and is already set up or getting set up, they're all going to have a high carbon tax. In Canada, in Europe, in Singapore, they're going all this in USDs. Okay. In India, the concept is very interesting. We talked about that we apply the carbon taxes for compliance markets only. So compliance markets means those who government has already identified them as pollution causing industries. So they said that then they have to either have a adjacent industry which is renewable, and the renewable give them some carbon credits to offset off the so-called carbon taxes. But even now it is very minimal as of today. But by 2030, that may go up. Again, it's on the in how the government takes up these taxes, but it can go as high as $70 to $90 per turn for the compliance markets, not every industry, compliance markets. So this is something, and carbon credits will continue. Carbon credits can not necessarily, you can only buy from your own company. If there is a third party renewable company, they can sell you the carbon credits, and from there, when to buy from that third party, and then they can offset this taxes. So this is going to be very interesting scenario going forward in 2030 when we are going for this. So not only carbon tax, there is another thing which is going to happen by 2030 is certain airlines, again, not in India, not in the Southeast Asia, and not in Australia, but somewhere in the US and somewhere in the Europe. So there is a drive that for the aviation fuel, which is the flights, we are going to have what we call as they will only be allowing the green fuels, which is the SAF, which is sustainable aviation fuel. So green means they call it the biojet up there. So but in India, again, that is not enforced. One of the things, we are still a developing economy, and it will not be, and we will not meet the energy security and in energy equity if we try to force. So that enforcement is yet to come. I'll try to go from this somewhat boring topics, but I would like to emphasize that this is still important for us. This terminology, global warming potential, I do not know, like if you see this word nowadays more or not. So imagine if carbon dioxide causes an effect of making the earth warmer by 1 degree, and we call this potential, the global warming potential of carbon dioxide is 1. In compared to carbon dioxide, methane has 28 times more. So if you are emitting 1 kg of carbon dioxide versus there is an industry, I'll give you an example where the methane comes from. Methane may come from, for example, a LNG plant. And the LNG plant, there is always, they call it the one of the last units is a nitrogen rejection unit. So where they reject the nitrogen which is there in the LNG final product. So there is a nitrogen recovery column, and from the nitrogen column they send out the nitrogen. But along with nitrogen, 4% of methane is sent out directly to the atmosphere. So imagine that 4% of methane is as dangerous as 28 times the carbon dioxide global warming potential. I would not like to tell you the exact definition, but just you can imagine. So carbon dioxide to methane ratio is 28. The only silver lining, or the only saving grace in this entire thing, is that methane is not released as frequently, as much from vehicles, from other places, as common as carbon dioxide. So carbon dioxide is the single largest, by economy of scale, this is the single largest emitter. But then we have methane. Last time, SF6 or sulfur hexafluoride was used extensively in the MCCs, the motor control centers of many of the refineries. They have banned it. They have gotten another chemical on this MCC things. So basically, it is to ensure that it's just a purging medium. So it's not doing much. It is just like a blanketing medium, so that it remains what it is supposed to do. Basically, there are certain requirements related to the motor control system, electrical systems, substations in the refinery. So now SF6 is totally banned. So it is something like fluorocarbons were banned at one point of time in the aircon industry. So this is also getting banned. So you can just see there are many other. So perfluorocarbons, we just talked about those fluorocarbons, right? So this is 11,100. So that is why if you know that you got it banned, whatever was there are certain kind of refrigerants which have been banned from the air conditioners. So this is the reasons why the hydrofluorocarbons and perfluorocarbons are all out there. Nitrous oxide is an emission coming from nitrous oxide is in one of the emission components which is coming from various industrial effluents as well as somewhat from the petrol diesel cars. So to reduce this nitrous oxide NO is also one of the major drivers of many of the current industries today. So this cloud although looks very like naive, but actually it has got a lot of implications up there. But remember this one thing, that it is not as direct as it seems to be. But for now, I will just skip this slide. We have to consider more things in here, but as a general understanding, this gives a fair enough idea. Global agenda, we are going for renewables, low carbon, decarbonization, defossilization, net zero. Okay. Net zero and green energy transition, clean energy, carbon, other emissions. I'll not go in this one. Types of hydrogen. Okay. Types of hydrogen, you have heard of green hydrogen, I'm sure. So green hydrogen, right? What is the definition of green hydrogen? Green hydrogen is developed from renewable energy. So imagine that if you're using a hydroelectric power, which is a renewable source of energy, and that you are using or even from a wind farm, and that you are using to as a that power you're utilizing into the electrolyzer and then producing the hydrogen, then it is a green hydrogen. A gray hydrogen is something where it is from the natural gas or methane, in like what we used as the PSA, pressure swing absorption technology. That is what we do in the refineries today. So from natural gas, we go for certain chemical reactions and then we create hydrogen from there using the reforming reaction, etc., and moving forward, and then followed by the PSA, pressure swing absorption. So that is called the steam reforming. And from the steam reforming, one of the, so if you see it's all about the source. The source is natural gas. Natural gas is supposed to be coming from fossil fuels. So that is why it is the gray hydrogen. I will skip the blue, black and brown and pink hydrogen like from nuclear, etc. But this is a very important term. So whenever you hear the word green hydrogen or green diesel or biojet, that means that the feedstock has actually come from a green source. Okay. So can you, I mean, if anybody can anyone tell that how can the diesel or biojet come from a green source? I believe that some of you must have known jet alpha is very common, but in sustainable way, I would say that what is there today for biodiesel and biojet, the main feedstock is the main feedstock is plant oil and tallow oil. So plant oil and tallow oil is like vegetable oils, and tallow is coming from the animal fats. So whatever is being those are the extras which we are taking from the so-called resources directly from the plants and the oils, or even used cooking oil. That's why we are saying that we are taking for greener sources and not from fossil fuels. So whatever we do to whatever technological change we make to make this source viable is something which we are calling as the green. So green hydrogen, end product being green hydrogen, green diesel, green petrol. Okay, I'll quickly move to the hydrogen. So hydrogen, right? So hydrogen, the biggest problem today, why the hydrogen vehicles are still in a concept stage, is because the problem with hydrogen is where do you store them? Compressed gas is a problem, compressed cryo is a problem, liquid hydrogen, how to put it, or you put in a adsorbent way, or you put in some kind of interstitial hydrides, complex hydrides, or you put as a chemical hydrogen along with ammonia, you store it. So so all these things are there, and which is still the sustainability is still halfway. Why halfway? Is because if you produce hydrogen from PSA, that conventional, like from the natural gas, the cost of hydrogen production could be as low as $2 per kg. If you do the same thing with respect to uh, the green sources, then it can be, the cost can be as high as $7 to $8 per kg USD. So that makes it always economically unviable, and that's the issue. Storage of hydrogen, we need like 350 to 700 bar. It's a huge pressure. Just to give you a perspective, your tire is around 2.5 bar gauge. Okay, so against tire, you are talking about like 350 to 700 bars. Just imagine what kind of thickness the metal will be requiring. Okay, I will skip this slide, and this is on hydrogen. Basically, what is the technical specification? So we have to give that what kind of technical acceptance criteria is required, and what type of technology are we using. So we prepare those materials which are the input. Starting input is called a technical specification. Whether you are going for alkaline, PEM, solid state. So this is true for any industry. We have to first come up with a technical specification. Then there are 5 stages. I will, interest of time, what I will do is I will try to make it faster. So because I want to move to our industry, which is the oil and gas, and so for any project, these are the typically 5 stages, and to make it simple, I will call it just 3 stages. First stage we call as concept and pre-feasibility is one stage. So 1, 2, 3, whatever you see is a pre-feasibility. That is the time when we go for plus minus 50% cost estimate. We come up with a concept, and and it is the client or the sponsor. We go for, the sponsor decides, or the client company decides, okay, our cost is going to be plus minus 50. How much is the return of investment I'm going to get? And they call it the gate 1. So 1, 2, and 3 forms the gate 1 for any company. The gate 2 is the feed. So gate 2 is the time when they give this information, they pass it on to a contractor, a design company, and they say that give us a cost estimate which is plus minus 20%, for example. So this gives, once they have come up with a more accurate, they will come up with all the design details. They will get contacts from vendors, they will get quotes from vendors, they will get all the things what they can get from vendors. But remember, there is no PO placement, there is no purchase order yet, no procurement, no buying. Until there, we are still checking the feasibility. Until this point, the second stage being the feed or the front end engineering design. At this point, if we have come across that it does not meet, then it does not meet. If it does not, once we have gotten a cost as low as like plus minus 30%, sorry, plus minus 20%, let's say, until the feed point, then then this cost will be given to the client. Client will look at it, do I have the budget? Does it give me enough returns? And if he is happy with his assessment, then the client will give us, okay, let's go for the project, let's go. And that is where the final stage, which is the detail engineering, comes in picture. Detail engineering means they have given a go ahead, then we are talking where we have all the orders to the vendors for the big equipment, small equipment, piping, whatnot, and eventually it will all end up from detail engineering, means the detailed design, from design phase to install and commission. I believe many of you you are aware of this process, but I just want to determine. Basically, it's very easy to look from a non-industrial background that we are having a great technology, but why is it not getting approved? It's the business case which has to meet, and the business case is until the stage kind of 4. So until the business case is justified, many of the SAF plants by Shell or other companies, even Exxon, they have shelved the project, they have stopped the project because it did not justify for a viable business case. So while we always talk about having a energy transition, and if the bigger companies, they say no, it is not making a business case, it will continue to fall back on the old fossil fuels, which is still cheaper. There is a lot of abundant oil and gas in the Gulf, in the US, in Russia, and still a lot to go. So we are going for, so that is why they will always continue to be cheaper. Okay, balance of plant. I am skipping this slide. Basically, this is like for a typical hydrogen plant, that what do we do for balancing? Balance of plant is nothing but how much of for producing like one, but it is I'll try to give it a very quick overview of what this balance of plant does. Is basically we were saying, right, that a hydrogen is until hydrogen is $2 per kg. That is what we said, the cost of making hydrogen. So but that is not the end of it. We also want to see, to make like 1 kg of hydrogen into the fuel cell, how much of water is required. So the water required is 13 liters to get one, and how much of power are we going to produce from 1 kg of hydrogen? We are going to end up with a fuel cell battery of 2.1. But to get to 2.1 and to get this electrolyzer working, imagine that we are needing 50 kilowatts of hydropower or renewable energy. So from 50 kilowatt, we are getting only 1.9 or 2.1 kilowatt of energy stored in the fuel cell. Somebody will say that why are we doing so much? Why not we simply continue to use the renewable at 50 kilowatt? We are getting, let the end user use the 50. Why are we so much putting so much effort to get hydrogen fuel cell which can only give me 2.1 kilowatt? The answer lies in the fact that the renewable sources cannot store energy. Even with a flywheel, you can only store for 15 good minutes. Flywheel concept also. So the technology has not developed that once you are generating on a continuous basis, you have to let go of it. You have to throw it away, literally. So instead of throwing that excess energy, what the plan is that if you can have an electrolyzer, a PEM electrolyzer, which can make hydrogen, and from there you can generate a fuel cell, then the fuel cell is capable of 2.1. So from 50 kilowatt, you can only achieve 2.1 kilowatt of this thing. So there is a lot of losses attached to along the way, if you see. And not only that, we need a dim in water as much of 13 liters for 1 kg and corresponding to 2.1 kilowatt. So imagine if I want something like 100 kilowatts, which is 50 times of this. So I will need like 50 times 13 liters per hour of consumption. It's a very high consumption, so to speak, for from a utility perspective. Sorry, 13 liter in total. So basically, right, there is a lot of utility also required, and dim in water does not come directly from groundwater. You have to have the dim in package, get dim in, convert the normal water, go through several stages of treatment, and eventually get the 13 liters. So there is a lot of losses involved and a lot of water involved, so which is also as precious as this. So the idea of giving this thing was that even when we say hydrogen, there is a lot of issue with hydrogen, that you cannot simply say, I want hydrogen, I like hydrogen, so I'll make one. No, does not happen. Okay, I would like to touch upon something more closer to what we do on an industry basis. Okay, so I would like to touch upon 3 topics. Topic number 1 is that everyone understands the fact that we are having a lot of power plants. We are having a lot of flare stacks today, continuously emitting out the so-called gases which are contributing to the greenhouse, right? So this is nothing but the carbon capture technology. What it does is that we take the flue gas from a stack, via a blower we send it to the so-called CCUS system. So this is based on the lean, this is based on the similar like amine treatment units, where you have a contactor and a regenerator. So the contactor comes with a solvent which is like going cyclically. There is very little bit of solvent losses. It's just going in a recycle way. So we are recycling the solvent, making the solvent richer. First, like the solvent is like a special solvent which is either from Shell. There is a technology, Shell has got a solvent, Mitsubishi has got a solvent. So the concept is same. It is an amine based solvent with certain special chemicals in there. That solvent will absorb the CO2, whatever is there in the flue gases or in the fuel gases. So whatever is there, it will contact along with this in the solvent, and eventually whatever is getting out of the stack so basically you are having so much of CO2, up to 4% CO2. So out of that 4%, 80 to 80% of the CO2 will be absorbed by the solvent, and the stack what goes out of the stack, say if it is like 10% was there, then 80%, so it's only like 2% we are emitting. So we have reducing the emission to a very low number by con- by by contacting the so-called flue gases or the emission gases with the solvent, and we have almost cut down the CO2 emissions and eventually the global warming potential of that industry to very low numbers. So this is coming as a common one. And now once the CO2 is absorbed in the solvent, this solvent is going into the regenerator. The regenerator, what it does is, there is a reboiler up here and everything. So whatever is the CO2 is getting boiled up, and then it is further via the overhead, it is getting collected down there. And this so whatever is coming back is the solvent, and what goes as a gas stream is nothing but CO2 of 99% or higher purity. So whatever carbon dioxide was supposed to be going to the atmosphere, that CO2, we are compressing it, we are liquefying it. So followed by a mechanical refrigeration, which you see up here. So we liquefy up to minus 30 degrees C, and that minus 30 degrees CO2 can be further either converted into the CO2 and disposed of into the earth, okay, or if this CO2 has got a usage in certain industries, certain specialty chemicals actually use CO2, so you can actually integrate them and sell it back to them. So CO2, as long as it is not sent back to the atmosphere and we can find some disposable grounds or some kind of usability, then this becomes extremely attractive. So this technology, the CCUS technology, is the first technology which I'm talking going. This is the first way, but it only reduces up to 80%. Having said that, it reduces to 80%. It comes up with its own indirect usage of fossil fuels. You need pumps, you need reboilers, steam. So where is the steam getting generated from? All the steam is getting generated by burning some fuel gas or something. So to ensure that you get lesser and lesser CO2 from the stack, in a way you are burning fuel gas somewhere in the boiler to get steam, and that steam is getting used as a utility to this reboiler. So it's always the pros and cons is always there. So you cannot say the pros and cons are always there. You cannot fully say that this is a perfect solution. Okay, this is being developed in such a way that that the heat integration of the refinery can be done in such a way that we do not do more than what we are doing and try to maximize on the heat integration. So that becomes a very interesting challenge. And to be very honest, I worked on 2 feeds of CCUS. Feed means the front end engineering work, and it did not pass through the gate 3, which means it did not go to the detail engineering stage, which means this project were shelved along the way. So it is a great technology. It's still in inception. There are things to be done. But it is there, and we can achieve 80% reduction. One of the prerequisites of this reduction is that the CO2 in the fuel gas has to be at least 5% or higher, is the thumb rule. They say 4%, but at least 5 to 7%, 9%. The more the content of CO2 in the gas up here, the more is the effectiveness of the CCUS unit. Time check. Okay, we are not bad. We are going good. Okay. So this is the CCUS technologies I was talking about: shell can solve technology, floor economine technology, carbon clean. So all these are licensors. These are the technologists which are involved today in the same, the eventually it is the same setup. Eventually it's the same setup, just they have their own solvents. Every solvent has, it's got some advantages, some disadvantages. Some can take care of more SO2 laden fuel gas, something can do more of one advantage over another. So they have their own advantages and disadvantages. The key concept: solvent absorption followed by regeneration. CO2 can be further cooled by mechanical refrigeration and stored in cryo vessels. CO2 removal efficiency, it says 90, but I have seen more on the 80 side. Key selection criteria is minimum regeneration energy, which I said, which is the difficult thing. Advantages against certain contaminants: example, Canaslov property solvent is resistance to high SO2 concentration, thereby giving you a better removal of carbon dioxide. This also was there. This is the second concept. So just now what we discussed was that there is a flue gas and we remove 80% of CO2. Here there is another interesting fact. What we do here is that we want zero emissions across offshore platforms, across other locations. We want zero emissions. We don't want even the 20% to be lost and things like that. So what do we do out here? What do we do out here is, so there is a flare gas that is supposed to burn up here eventually in the flare stack, and which will emit the CO2. Why flare gas? Normally there should not be a gases which should be flared, but during startup, during some kind of upset scenarios, some pressure relief has a valve has popped up due to some emergency. I can talk more and more, but there are situations when you cannot avoid sending some of the off-spec gas which you cannot utilize and sell, and that you have to send it to the flare and burn it. So there is a burner up here. Now, to minimize this flaring, because anything you burn, it will emit CO2. To minimize this flaring, this tapping, if you see up here, if the design is that they call it the zero emission. So basically, the moment there is a high pressure in this line, they will open up and start the compressor. This compressor will take in whatever gases is there. It will, that they will try to put it back into the process system or into the source where it was taken from, and we will wait it for further for further processing. We can, as long as we put it to a location where it can be further processed in the same refinery system, in the same system, in the same kind of setup. So there are locations in any refinery where this gas can actually be added along with the normal gases, and it can be as a feedstock to some of the processes. So by doing so, we are not allowing the flaring to happen, and we are not allowing the CO2 to get emitted from here. This is becoming a more and more prevalent concept up there in offshore platforms as well. This is in refinery also. The flare gas recovery units or the fuel gas recovery units are becoming common. And in many other industries, this is where we want zero flaring. This is coming. So interestingly, this concept was there. I had heard for the first time somewhere in 2005. Just that they are making more and more of these nowadays. Okay, somebody will say that can you find the avenues to put it back into the process system? It's already flaring off, already off gas. Do you have the excess capacity to handle when you put back into the same feedstock system? Yes, it can be done. That is why this concept is here. Okay, if it was not there, this concept would not have made ground. Everything comes at a cost. All these compressors, all these things, they do come at a cost. They come with indirect emissions, because to operate this compressor, you still need energy. To operate certain kind of coolers, you still need water to, and that water is coming from a cooling water system. That pump also needs energy. So where is that energy coming from? That energy is coming from fossil fuel. They are there, but not as bad as you directly emit into the atmosphere. So this is the FGRU concept. So I actually wanted to touch upon FGRU, CCUS, and the third one is the SAF and renewable diesel. So this is something which I had actually spoken a couple of minutes back. So the idea is that if there is an existing refinery, what is the feedstock to any refinery? It is crude oil. Okay. Now, with today's economics, what is happening is the crude oil is getting less and less. sorry, it's not, many of the refineries are closing down, they're mothballed. So instead of using crude oil, we can actually use palm oil. We can have a pre-treatment unit, because unlike crude oil, palm oil and tallow cannot be straight away used. They have to go ahead with something called, they call it HCO, or hydro cleaning system, or a pre-treatment unit. So they have to make sure that they take care of the gummy substances, etc., and some metals to be removed, heavy metals which are there. So they will remove all those things to be able to send to the actual processing unit, which is HEFA. HEFA is nothing but heavy esterification of fatty acids unit. So it is similar to what the hydrotreater units, the hydro desulfurization unit, the hydro isomerization unit, and basically it all does is by doing this and doing with all the separations like a refinery, similar to a refinery, with similar kind of fuels, similar kind of utilities, we eventually can get renewable diesel, sustainable aviation fuel, and naphtha as the final products. So this, the thing is that I could have shown you with a PFD, but unfortunately there are certain restrictions I can't show here because of confidentiality, but it is something available over the internet. You can find those things. UOP is the licensor. You can look at UOP technologies, etc. But basically, instead of going from fossil fuels, we can go here. Okay, I'll come quickly to something called simulation, for which I was also given as a topic up here. I wanted to come to the simulation topic again, going for a time check. Okay, still good. So yeah. So simulation, right? I'm sure that many of the younger engineers and the younger generation, they must have used this concept, simulation. You may have HISIS in your college curriculum, and many people might be better than me. Okay, that's okay. But the thing is, simulation, what is the use of simulation? What do we do in the simulation in process industry? How is it important to us? So simulation, what it does is that it has got certain fluid packages which can help you to determine the properties, generate properties, and simulate whatever you have put in the technology, right? Whatever plant you're putting up, it can simulate the entire plant as if it will be working as if, as designed, it is supposed to work. It will kind of simulate that, and you can validate the, if there is an existing plant model, actually running plant, you can model the same, be it chemical reaction, be it anything. So basically you can simulate it, and you can optimize the plant, you can validate the plant, you can debottleneck the plant with this thing. So what are the basics which are required for a simulation? So first of all, for any kind of component, you need to come up with fluid packages. So for example, if it is a hydrocarbon component, we say that in HISIS or in any other Pro2 or SimSci models, or there are other like PetroSim softwares. So these are this, whatever names I'm saying are the name of simulation softwares available across industry. So we have to say that it's Peng Robinson is very common for the hydrocarbon industry, for example. So Peng Robinson is the fluid packages we'll choose, component list we will choose. So let's say your component is ethane, butane, propane, some hypo components, and then there is lighters, and then there is a crude oil. So crude oil has got more than 3,000 individual components. It's impossible to define the exact composition in a simulation model. So then what we do is something called, we call characterization. So instead of having a hydrogen, nitrogen, methane, ethane, butane, what we do here is there is a something called petroleum essays, or the true boiling point curves. So we input in the simulation software that what is the true boiling curve for the crude oil, and that is our starting point. So instead of giving a composition, we give them the characterization by means of petroleum essays, which are available from each of the wells. So they have they wells means from where the actual source. So somebody has done, and they have done the TBP estimate in the laboratory. That TBP curve is something which we ask from the client as a design basis, and we start putting up the that becomes our composition list. And if there are any reactions, we can define reactions. If we want to generate user properties like density, viscosity, vapor pressure, you name it, thermal conductivity or specific heat or any other data which you need on a day-to-day basis, these properties can be well generated. So this is typically for HYSYS. I am not this is the only software which we use it pretty common, so I'm just sharing this. But Petrosim also is very similar. Pro2 is also very similar. So we come up with components. So we have methane, ethane, ibutane, and so on. So we add the components. Then we define. So then we define the hypo components. Hypo components are sometimes the client, what they give is that not everything is comes as a proper composition. So they call it hypo, like pseudo components they call it. So pseudo components are like if it is somebody has already modeled it previously in HYSYS or something, then the properties we have from that model is that previous model, we only get the molecular weight, normal boiling point, and then we allow it to back estimate the hypo or the pseudo or the pseudonym or whatever you can call it. So we have a list which comprises of hypo, actual components, hypo, and the TBP. So we can use in any combination. We can use on whatever is available with us. If we have got lighters, then only lighters. If you have got all the actual components, then actual components. If we have got all the hypo, you can also use purely based on hypo. Or you have got the crude assay, then you can put in the crude assay and software will generate the properties. So, or a combination of three. You can also use a combination of three, and then you can put the input or the feedstock conditions can be provided. So once we have given all that, you see there are a lot of property packages. So for example, PR is pretty common up here. If there is a hydrogen, there is a hydrogen package. If there is a SRK, then there is a SRK package for certain kind of components. Lee Kessler. Then there are certain which is Antoine's constants. It is more applicable for some electrolytes. So there are various packages which can be used for us. So that there is guideline which package to be used. For hydrocarbon, like I said, we use typically PR. Then there is also, if it is sour service more H2S, then we use SRK. So then we can also put in the reactions. So reaction with the stoichiometric coefficients can all be well defined in here. We can have conversion, equilibrium, heterogeneous, catalytic, kinetic, simple rate. See, I know that I might be going a bit fast, but I will say that these are all the facilities available. It's nothing great. What I'm saying, you don't need to know. When you learn, you will learn. But the thing is, what I'm trying to say is that we have a component, we have the US selection or equations of state to be selected, then we have all the facility. We have reactor, we have line sizing, we have exchanger, you name it, it's there. So I will kind of skip the dynamic simulation, but I will try to make it something simple. That what can simulation do for us in oil and gas? Simulation can, if nothing, simulation can help in line sizing. So if you want whether 2-inch or 3-inch line size is required, but line sizing can also be done using an Excel spreadsheet or a flow assurance data. Then there is a control valve sizing. So if there is a control valve in the line, then again Excel can do it. Separator 3-phase sizing, yes, Excel can do it. Distillation column, this also can be done separately using Excel, or it can be used with proprietary distillation column. Either spreadsheets or by the solution. What does it do for us? You can include, if there's a control valve, you can put a PID controller, all the three things you can put up here. If there is a line sizing, you can put the pumps, there's a pipe, then there is a separator, then distillation column followed by heat exchanger, including reboiler, reflux, everything can be there. and there are a lot of functionalities inside that. You can do goal seek, you can adjust, you can set, and you can integrate, and you can run, and you can find bottlenecks, that where exactly is my design lacking in when you run everything together. If the same thing is done separately and individually, this will take time. When you do all as a single one, it will make it much simpler. I will tell you a very simple case. Okay, this case is a pump which has got a butane. It has got a certain kind of, it's a pump followed by line size, followed by control valve, followed by heat exchanger, followed by a vessel three-phase separator where whatever was there. So butane water mixture was there. And eventually we are, after doing all these things, we are pumping it from 1.5 bar to 11.5 bar. And we are increasing the temperature to say 70 degrees C, and then we are separating the water and water from bottom and the butane from here. I'm just putting a simple case. Now, if you see the blue color, it means that everything has converged. I have also put the level controller up here. Okay, that we want to maintain a level of 50% of butane in the system. So on the vessel, everything looks simple, but actually, right, this and it has converged as well. But what we need to understand is, when we have as simple a system as this, a convergence does not mean that it is correct. If you will notice, this is a very simple case: a pump, a line, pressure drop, control valve, exchanger, and this. But if you go to the next slide, what went wrong is, a pump should operate only on liquid phase. If you see here in the first slide, the vapor fraction was 0.8227, means it is, you cannot force in real life, you cannot force in vapor through a pump. Simulation will agree to it. Of course, it will give you a warning, but you have to be intelligent enough to know the warning. So there was something wrong. You should not have had a liquid at 30 degrees C. In fact, if you see what all was wrong, was you will see that the source was having a vapor 0.8227. Across a pump, there is not supposed to be much temperature increase. But what happened is, the temperature increase shooted up from 30 degree to 139. Okay, it's not possible to shoot up a temperature from 30 to 139. You know what actually happened in this case? When we developed, we thought everything is going great. We put up some numbers, and eventually it started considering it as a gas. And gas, if you compress from 1.5 bar to 11.55 bar, then it will compress, and that compression will, and based on the efficiency of that compressor, it will kind of increase the temperature to very high numbers. So instead of a pump, it ended up showing up like a compressor. The whole thing is incorrect. So we started with a simple case, but actually we wanted to converge. It did not converge, because for a pump, any pump pumps liquid. Pump does not pump gas. So this is where the thing went wrong. So to do it correctly, what we needed to do is that the pressure we had specified was below the vapor pressure of butane liquid. Butane has a vapor pressure of 2.86. So what I did is, I increased the pressure, source pressure, to 2.87, which is more representative and more correct. So you see that the vapor fraction is 0, and eventually everything is converging nicely, and we are getting a separation of butane and water out here. And across some places, which is in the stream number 13, because exchanger is increasing the temperature from 12 to 13. If you see 12, the temperature is 33, and 13, the temperature is 90. So because of that, the full, so whatever vapor was there, that vapor, whatever was the 13 is a two phase, so it became, so 12 was a inlet, was a liquid. 13 became a two phase. Two phase means more vapor, very less liquid, and of this, the vapor was eventually separated here, liquid was separated, water was separated. So this way we have to be intelligent enough to understand that thing. So I will there are a lot of other things which simulation can do. It can do cost estimation, it can do optimization, it can do operator training simulation, it can do digital twin, it can do Aspen Unified PIMS, which is production planning software, which means you can define that if the price of the last one, if say the price of petrol is going lower and you want to use it for you want to convert your refinery to a to produce say petrochemicals, naphtha more, then this PIM software helps you to plan the production and to make the streams distribution in such a way that it will give you the maximum commercial benefit out of it. So there are no limits, and with AI in picture, this is even going to be a game changer. So I will stop here. I had kept something for reserve slides, but that is not required for now. Let me see. Yeah, I will open the forum for questions. I know the time is short, and I tried my best to put up some interesting thoughts, and hopefully did not make you all steep. Yeah. So
Thank you very much, sir. Participants,
yeah, over to the forum.
participants, if you have any questions, you can ask now.
If you do not have any questions, I can actually continue with some more interesting things. This is easier to understand, not so difficult. I have just added three more slides. But if you can, if I'm getting questions, I will definitely take up. Let's see if we have that time or not.
Sure, sir. So participants, if anyone has any query, you can ask now. You can post your question in chat box also.
Okay, while you are having this posting these questions, I'll give you some very easy things. So, pictures speak louder than words. So let me tell you something interesting. So I have worked in three industries, like I said, pharma, refinery, and offshore. Okay, so offshore platform is I'll tell you something very interesting. So in offshore, right, you see this helipad up here. I hope my cursor is clear. So you see a helipad up here, and this is where the people will land. So where the helipad lands, then these are the living quarters. The yellow ones which you see up here, right, are the living quarters. They have all the things: living quarters, sleeping quarters, these things. And then comes the process platform. Process platform, they will always start with utilities like water, seawater, whatever utilities are there. Remember, in a platform, you don't have steam. You have all other utilities except steam as a typical thing. And then there is a production which is happening is whatever you can get from the wells, from the nearby crude oil wells or the gas wells. This is what you get in here, and you process it good enough to make sure that it can be transported into a nearby vessel. You transfer all the crude oil which is generated into a vessel down there, and that vessel will take away to the shore. So this is what we do. But what is special about a FPSO, or what is different from a FPSO from a refinery? So generally, the biggest difference is that FPSO, or a ship which is sitting here and it is taking all the wells, it is at a single location. It is for the next 15 years, it will be sitting in a single location. It will not never ever move. Okay, it is just taking from the wells, processing it passing the oil to the nearest tanker, and the tanker will come every 15 days and then take the tanker away, and then that will go to the shore, and that will go to a refinery, okay, like Jamnagar refinery and so on. So this particular thing is very similar to a refinery, minus the fact that there is no steam, and it is extremely congested if you see. So the congestedness will make sure that the entire design has to be very small and compact. All the equipments have to be very compact. There is one more interesting thing which happens in FPSO which does not happen anywhere else. That is, because of the wave movement, the ship literally goes, they call it pitch and roll. So front and down and side movement. Because of this movement, the vessels, right, they tend to tend to have spurious readings. The level transmitter will suddenly show a high level, but actually it is just the movement of the sea. Something has gone up or something has gone down. So we have to put in our design in such a way that those movement, because of those movements, whatever the movement of the oil or in the vessels, etc., has to be countered. So we have to keep margin on the alarm level and the trip level in such a way that working volume is if so much, we give a buffer to cater for the movement of the waves. And then so the vessels become slightly bigger compared to the onshore industry, and and this has to be catered. And for the same problem, many of the slopes which are given, there are certain requirement that the lines has to be sloped towards the flare header, the relief lines. So that slope has to be higher. It has to be, because to cater for that again movement, that is a very interesting thing. How people stay in the FPSOs, how they operate, how they do their day-to-day work is pretty interesting. I would compare an offshore straight away with a pharmaceutical plant. What difference do you see in a pharmaceutical plant? Everything is stainless steel. Everything you see is very shiny out here. Okay, shiny means this cannot afford to contaminate. Tomorrow you are going to eat a medicine, paracetamol. Do you want it to be contaminated? It has to be extremely clean. The air has to be clean. People have to be clean. The system has to be designed for good CIP, cleaning in place. HTLT means high temperature, low time. So if after every use, after every batch, it has to be cleaned with steam, cleaned with water, ultra pure water, not just normal water, not just RO water, ultra pure water. So steam is not just any steam. It is ultra pure steam, or they call it clean steam. Clean rooms, safety personnel, and the air, we don't want external air, so the rooms are slightly pressurized. The air in the room is slight pressure. So if at all something will go, it will go from in to out. Nothing will come outside. Dirt will not come into the system. So these are something which are very much prevalent in our industry. So, and refineries, as you all know, is lies in between those two. So basically refinery has a lot of space. Flammability is a problem. So the flammable gases people are handling, H2S laden gases people are handling, so they have to take a lot of PPEs means personal protection equipment, sometimes this masks, sometimes there are other things. So basically the safety to somebody to work in, but at the same time they have to deliver, they have to produce, they have to meet the production goals. So they have to have enough control and safety instrumentation in place to make sure these all work. So I'll quickly go back to the team again. If we have more questions, we have 3 good minutes, and if there are any questions, I can continue to take on. And I know it's an evening time. Thank you for your time. I mean, I can understand that problem. Yeah. Dr. Sushma, I believe if there is anything, please let me know. I can make the best of those 3 minutes. If there's none, it's fine.
Hello, am I audible?
Yes, very much, Mr. Anand.
Yeah. Sir, my question is like you talk about clean steam. So, what are the parameters that you need to look into that it is a clean steam? Like you talk about in the pharmaceutical industry, that the hygiene is the highest priority. Right?
So normally, right, what happens is if you see any of the boilers in the industry, you used fuel gas, right? You use water in a boiler. You put the fuel gas, you heat up, the water boils, it becomes steam. That is a normal, what we call as the gray steam or the black steam. With
Uh-huh.
respect to pharma, that is called black steam. So if you use that black steam, you cannot use it for the pharmaceutical industries. Okay, that black steam is not allowed because that still contains some kind of impurities in the air, some kind of hydrocarbon in the air, some kind of things which are not allowed in the pharma industry. So first thing is you cannot make steam out of fuel gas, and you cannot use the normal water. for using this. So first of all, you have to go through several stages of ultra pure water to get ultra pure water. You can Google ultra pure water. So there are several softening things, then followed by certain what do you call that, some regeneration and sorry, some kind of preparation, some kind of things, and eventually you get very pure water, which is like
Sir,
very
RO
low
water is ultra pure water.
no, RO water does not qualify for it. The RO water still has something. So basically, ultra pure water requires even more rigorous treatment, and it has to meet certain micro Siemens in terms of conductivity, that it should meet less than 1 micro Siemens. So it has to be, the process is similar, but the process is stringent, means the technology is more stringent. You can Google it. It is similar to RO, but even more pure than RO. So after you get that pure water, you cannot say, also you cannot directly put it into the boiler and say, I will boil using the fuel gas. So what you need to do is to generate the clean steam. You use ultra pure water in the boiler, but you use black steam as the source. So you use a higher pressure black steam to generate a lower pressure ultra pure, sorry, to clean steam. So this steam eventually becoming from ultra pure water, then also it will pass, before that it also, the ultra pure water, it passes through a scrubber before it is entering into the boiler. So basically there are a lot of stuff which we have to do, then it qualifies as clean steam. This clean steam is eventually also used for big pharmaceutical, like the vials, right? Vials means the bottles, also to do that sanitization. What do you call that? The high temperature, basically more than 100 degrees C. The word I'm not getting. So that sanitization, to do that, they use clean steam. So it is pretty much a technology in itself. There are specific vendors like which can provide this thing.
Thank you, sir. Sir, one more question. Does the HENS, you might be knowing HENS, that is heat exchange and networking, is still a part of sustainable development, sir?
Haynes, first of all, please don't call me Sir, Mr. Anand. I believe you are a very senior person. So thank you for your help. The heat integration, right? I have seen it since 2005 or 6. It has been a part. See, sustainable is a very broad word. Means we should not limit it to the fact that it is energy security and this thing. So even a simple recycling of material is also sustainable. So heat integration, yes, in a way it is definitely the extension of HEMS is actually the pinch technology, right? And there are pinch softwares available today. So pinch technology is also a way where the heat integration, by means of heat integration, we are eventually achieving lesser and lesser losses, or maximizing the heat exchangers. So that is definitely, I would say yes to that answer.
Okay, thank you very much, sir. I really enjoyed your lecture, sir.
Thank you. Please don't call me sir. I will again request. I ask my younger engineers. You are a senior person. You are probably doctor as well. I'm just saying this. Okay. So don't do that. Yeah. But yeah, I will be most thankful if there is anything. Yeah.
Okay. Thank you, sir.
Any other questions? So we conclude here today's session.
Thank you, Sushma madam, and thank you for the opportunity. I hope you all can have a good dinner. I don't know if you are having another session back to back, but try to take a break and try to give the listening members a little bit of respite. Yeah.
Sir, we have continued sessions.
Oh God. Okay, so maybe this is the concluding day, right? So it's okay. One last effort, and then you should be good to go. Okay.
So on behalf of organizing committee, I sincerely thank our session expert, Mr. Gaurav Sinha, for his insightful and informative session. He effectively explained key aspects of renewable technologies, wind energy challenges, and hydrogen technology, including global warming concerns and the type of hydrogen and their production methods. He also highlighted zero emission strategies, defossilization, sustainable aviation fuel, and renewable diesel. In addition, he clearly explained the role of simulations in the oil and gas sector, particularly how simulations help in analysis, optimization, risk reduction, and decision making. The session was highly enriching and well appreciated by all participants. We are grateful to Mr. Gaurav Sinha for sharing his expertise with us. Thank you, sir. Thank you very much.
Thank you, madam. Okay, I'll log off then. Yeah, thanks.
Yes, sir. Yes.
Thank you.
Participants, just wait. Our next expert is join short.
Hello, Shushma ma'am.
Yes, sir. Welcome, sir.
Good to see you all. Yeah, yeah. It was really, I mean, like good interactions I have seen.
Oh,
Uh,
yes.
Most of you may be very tired now, you know? And some
So,
of
shall
them,
we start, sir?
uh, yeah, we can start, ma'am. Yeah.
Yes.
What about if
So
you want to
now,
take a break? It's okay. You can take break, no problem.
no, sir, it's okay. So we start with our next session. Today we have our expert, Dr. Suantak Kamsonlian. He is an associate professor in the Department of Chemical Engineering at MNNIT, Allahabad, serving since 2012. He holds a PhD in chemical engineering and an MTech in industry safety from IIT Roorkee and a BTech from Kerala University. His research expertise includes environmental science and engineering, electrochemistry, biochemical engineering, and wastewater treatment. He has published over 35 research articles, presented over 30 papers at national and international conferences, authored 10 books, and contributed 12 book chapters. Dr. Kamsonlian has received research and consultancy funding from agencies such as SERB DST, ANRF, DBT, TICWIP, CPCB, and UPCST, and holds 16 national and 10 international patents. He also has prior industry experience as a safety auditor and actively contributes to academia as a professional member, reviewer, keynote speaker, and resource person. I request sir to kindly proceed with this session. And welcome, sir, to the FDP.
All right. Thank you so much, ma'am, for the wonderful introduction. I don't know
Welcome.
whether uska like honge, but I'm thank you so much that like this today's last sessions, I guess, Hannah.
Yes, sir.
All right, all right. Let me share my slide. It's not coming. Just wait 2 minutes. Wait. All right. Okay, ma'am, is it visible?
Yes, sir, it is visible.
All right. Okay, thank you so much, everyone, and very good evening. My name is Dr. Suantak. Right now, I'm working as an associate professor in Department of Chemical Engineering. I am very happy that to be a part of faculty development program today, emerging trend and research frontier in chemical engineering for green and sustainable future, Vidyadeep University, Surat. And today we're going to discuss about wastewater treatment for green and sustainable future. This is very appealing to me that like green and sustainable when we talk about, because we keep as an we keep on changing as an engineers and all, like innovations and all. We talks about like smart sustainability, all those things, but the terminologies, it linger in my mind that like many of you maybe heard that like mm, organics we talks about, like pehle wo hota, I mean like green, then organics it comes like that, and also I mean like there's good things. Anyway, uh just not only the I mean like I'm delivering or speech or something like that. It is more about discussions we'll have today in this session. Okay. And every one of us, I mean like familiar with wastewater treatment, and also, I mean, like, it's a very basic things that like most of you may be so much aware, and some of researchers also working on it. So I know that like what I have seen that your series of presentations here. So I think that most of them are talks about water conservations, membrane technologies, and other sustainability and all. So I mean, like, you may be much familiar. What I'm going to talk about is you may be very, very much familiar about it, but still, for some people, it may be a brush up for you. So that like what we can learn today and what you can take away from these presentations, right? So in these presentations, like I'm set up in a very simple way that like it will be easy for you to catch up. So that I'm just going to touch that overview about it actually, and what we are doing in our lab. That is what we're going to talk about, right? So first things first, that like a wastewater treatment, what is exactly, what are the sources and all we're going to talk about, and what is the present scenario about it, and why it is so important to treat wastewater, and what could be the technologies, what are the ongoing technologies, what people are implementing in their plan and all, and what research is going on. That's what we're going to talk about, and what are the benefits that like what treatment of wastewater for the sustainable development. And we can also talk about like SDG, that is what we call sustainable development goals. What are the goals, right? Then we're going to move on to our lab and what kind of research we are doing in this year in MNNIT. That is what we're gonna talk you. Okay, first thing first, many of you knows they like wastewater actually. So wastewater can be categorized, okay, like domestic, industrial, agriculture, and stormwater and all. So the basic thing is that like when we talk about this wastewater, it could be started from our household actually. If we can treat, if we can maintain the waste from our households, then how much we can save, how much we can give impact to the environment. So this is the, I mean, like I was pondering that like rather than that using different technology, investing so much money, why can't we, I mean, like concentrate in our household? Then we could have saved lots of left sorts of money as well as lots of resources we can save. So when we talk about waste, it is more about the contaminants. We in this right now what we're talking about is the contaminants, the pollutants, that what water in the water, all the pollutants and all. So how to remove these things is very, very crucial actually. Like traditional approach we have, modern approach we have. In traditional, earlier what happened is that like mostly we focus on the purification. Okay, before discharge into the surface water in industry, effluent treatment, we are concentrating on that, and public health. So it should not have an impact on the environment. This is the traditional actually earlier. But in the modern approach, we are not only interested in purification. Okay, so recovery, what we can get from wastewater. For instance, like the 3 R's are there: reuse, recycle, recovery. So this is what in the modern researchers we are focusing on, like what kind of nutrients we can recover, and what kind of, I mean, like energy we can get from there, how much water we consume, and how much energy we can generate from it. Okay, and of course the cleaning of water. Okay, clean water, of course we are using mostly the things that like reuse. Okay, recycle, reuse, zero discharge, all these things what we're going to talk about today. Okay, so in a basic things that like all these things, but I'm just giving you the, I would like to brush you up that wastewater treatment, when we talk about, there are certain of stages are there, right? Like primary, secondary, tertiary, before that preliminary and all. Okay, so here in the treatment, whether it is advanced treatment, yeah, in the conventional treatment, yeah, traditional treatment, these are the primary things that we learn in our schools, in our colleges. We learned that like what is primary treatment, secondary, tertiary. Now we are a little bit advanced. We are using different type of technology. Okay, most of the researchers, we are focusing on advanced treatment. That is what we're going to talk about. All right, as we see the scenario, actually the worldwide scenario, we can see that like how many country has adopting the green and sustainable methods. All right, so if you see there are 4 categories. The first one is I just make it in the green color. That is what we call is they are more concerned about the sustainable and green technology. So they could achieve not 100%, but nearly 100%. They could achieve the country like Sweden, Norway, and Japan and all. So they are more focused on the greenery and this type of sustainability. But India comes under the third category. I consider it as a orange color. So India, Russia's and all, they are still in the progress. That like due to urbanizations, maybe that could be the industrializations. That's why like high pollutions of rivers, groundwater, we are still having this kind of problems which still we are facing. But the government is taking lots of initiative like Namami Ganga and all those things, and I'm also part of it. So we're trying hard. Actually, like pollution control board also they are trying hard. They're like in the Kanpur area, for example, in UP. So there are so many effluent actually. Okay, some from tannery, textile. So there are online monitoring systems they are installing. So from there what happened is that like earlier people used to go and inspect. Okay, so when they inspect, sometimes there are some gap is there actually. They could not able to rectify. Yeah, they could not able to like streamlined it. So it is so many flows happen. So now the government has introduced online systems. So they are installed in most of the industry. They have installed some sensor so that like they can monitor the pH value, the BOD, the COD, and TSS, TOC, all those things. It comes through online. So if some things goes upper hand or it cross the limit, then what will happen? It will give an alarm so that like the message will go, you should reduce your COD, you should reduce your BOD. So those kind of monitoring is happening in India also. And so it's a progressing, I should say. And the countries like in red mark, what I'm showing is that like some of the underdeveloped countries, they are facing this kind of lots of problems like wastewater treatment was not adequate. So there are scarcities of water, and this kind of technology they have to. I mean, like if you think in a global, not only in the nation, if you think in a globally, so some of the countries they need to improve a lot actually. So in these statistical things, in these qualitative studies, you can see that like the color coding. If you see these metrics, then you can easily identify that like which country or which continent did the best things and what we need to improve. And based on this NITI Aayog report 2023, I've go through the like it is very interesting. If you can see these statistics, then you can see that like as sewage generation is almost like 72,000 MLD, then installed capacity is around 31. So there is a huge gap actually. If you see, around 60% of gap is there. So what could be the reasons? Then untreated sewage water is around 41,000 MLD. So here most of the like researchers were talking about that like underutilizations of existing STP due to incomplete sewage connectivity, maintenance challenges. So these are some of the concerns that we, the citizens of India, we should think about it actually. The metro cities, if you see Delhi, Mumbai, Bangalore and all, if you just see that how much they generate, like 40% of total sewage and all. So it's a high time that like after these graphical representations, we can see that like the cities, the class 1 cities, what we talks about. So how much gap, how much improvement we need. So that's why wastewater treatment is a very, very critical in these places. So I mean, like we need to focus on it. And moreover, in the next slide, we can see that like why the importance of wastewater treatment, why it is very, very much needed actually wastewater treatment. As we know that like we all know protections, public health, like drinking water is one of the main source of our living. So we need to have a good pure and safe drinking water is very, very much required, and it preserve mostly like if we cannot treat properly, then what will be the impact, not only our health, but it can impact on our ecosystems as well as our environment. So mostly the important wastewater treatment is urban industrial growth. Of course, it is very, very important. Then sustainable development goals also each achieve. Then when we talk about green and sustainable methods, what green and sustainable method? When we talk about it, it is more few utilizations of our natural resources, right? Water, energy, land, and raw materials. The same as like we should generate as minimum as possible that like pollution, like low waste productions, reduce emissions. So these are comes under the green and sustainable methods. So what kind of are we really implementing this kind of sustainable method or not? That we have to see ourselves, we have to evaluate ourselves. This is very, very important, and it is also safe for human ecosystem. Okay, then economical viability we talks about, and support long-term environmental balance. So when we talk about environmental balance and all, it's very much required as circular economy principles. Then I was talking about different type of R's like reuse, recycle, and remove. So I mean like recovery of energy, recoveries of nutrients. So all these things, it will impact on a long-term process. So we need a sustainable and green method for a treatment of wastewater. I just want to highlight that like different type of technologies nowadays people are implementing, and in country wise also I'm just giving you some examples, okay, so that it will give you a little bit idea about how people are working on it and what kind of projects people are implemented. Okay, like for examples like source separations. In this source separation in Sweden, they have come up with a one project very, very crucial. I find it a very interesting. We could have implemented in India also. I don't know what could be the feasibility, but here, as we know that like the urine contains 80% of nitrogen and 50% of phosphorus, right? So in the commode, they have designed in such a way that the solid and the liquid they separate it. Okay, so they separate so that like the solid waste will go and the liquid waste will be moved. They separate it in other ways so that they can generate. Yeah, they can. Uh, someone.
Excuse me, all the participants, please
Oh.
mute your mic.
Okay. So by separating these solid and liquid waste, so we can generate from a liquid, we can generate, I mean, like very important nutrients, nitrogen, phosphorus, and all we can use, and it can be utilized for a urea and fertilizer industries and all people are utilizing. So this kind of fertilizer recovery, low energy demands. So this kind of very simple and very sustainable type of wastewater treatment we need to implement in our country as well. So it was successfully implemented. If some of you may be traveling abroad in Western country and all, you may be seeing that like how people are recycling their domestic waters and all, and it can be used for potable as well as potable water. So first time also when I went there in Europe and all, I was a little bit reluctant to drink that recycled water and all. But anyways, this kind of culture we need to inculcate so that like in India also we can grow actually. So that the scarcities we talks about the sustainability. If we're not implementing or if we're not inculcating, then this kind of things is, I think, little bit gap is there. So we need to think in that way. Then another thing is very interesting. One of the in like textile industries and all, I've seen in Kanpur now. Of course, they are implementing zero liquid discharge. So what exactly liquid discharge is? I mean, like some of the industry, the consumptions water is very high actually. So sometimes it is around per day we talk about millions, 100 millions of gallons per day. Okay, they consume. So in this case, they like what textile industries they implement is they like they recycle it and they reuse it again multiples of times, and they are not wasting, I mean, like water. Plus, I mean, like the treatment they are doing in their own plant, and so I mean, like they keep on utilizing for many rounds, I should say. So I mean, like the cost, energy, what their the resources, the energy for a treatment plant and all those things. I mean, like it's reduced much actually. I don't say that it's a zero, but they reduce a lot actually when they compare with the earlier the process. earlier what they have adopted the technology, and right now what they have adopted, that there are quite, I mean, like improvement is there. So zero liquid discharge is, I should say that, like not only in textile, in many industry we need to implement, so that like we can conserve water actually. So in this case also, I mean, like low treatment footprint is there. Then decentralized treatment, this is also one very interesting, like Borda, actually this is a German, they have started this project. So decentralized water treatment systems. So in many villages now they are implementing, and it, of course it's become successful also. Here we can get that low, what is sustainably gained. Our interest is what is sustainably gained: low energy, affordable, and resilient infrastructures. So this kind of, I mean, like you don't invest much money, but it is very, very efficient. So this kind of technologies also now people are working on it. So I mean, like I hope that, like in Viksit Bharat 2047, I hope we can also achieve this kind of, you know, I mean, like in all the villages and all, we can, if you can implement this kind of technology, of course we can become a developed nation. Like membrane bioreactors, because I have seen the like membrane technologies we talked about and all, membrane biofiltrations and all. Of course, this is also ongoing wastewater treatment, and many peoples are working on it. So I will not stretch, because membrane you have already lecture on these things, but this is also, I mean, like I'm just giving you the glance about it, what wastewater treatment, sustainability, the green, all those things. I mean, like you need to know all these things. All right. So water reuses, compact design, resource, these are some of the sustainability gained we get from membrane bioreactors. Then electrochemical treatment, yeah, bioelectrochemical systems, these are the electrochemical technology actually. Both of them are very similar, but the working process is a little bit different. All right. The electrochemical treatment in this case, we use DC, direct electric current. Okay, direct current we use. Then what will happen is that, like we stabilize, actually dissociate the metal actually from the anode side. There is a whether it can be a iron, yeah, it can be copper, it can be aluminum. But many people are working on it. Even they do the doping and all. So what happens is the metal dissociate from anode side, oxidation takes place. Then that metal oxide, then it agglomerate with the pollutants actually, the suspend particles. Then what happens, it forms a flux, then it settles down. So this is the phenomena. Okay, so in these electrocoagulations, textile industry, dyes, tannery, people are started, I mean, like they are using it right now, and it's achieved, I should say, that 90 to 99% removal efficiency they could achieve. And here the plus point is that they are not using any chemicals. Okay, toxic chemicals was not involved. So I mean, like this also, I mean, like one of the sustainable, like the industry right now they're using. And another very interesting part is the MFC. Okay, my microbial fuel cell. So this is also bioelectrical, I mean, like treatment process. Here the interesting part is that, like we are using microbes, yeah, microorganisms. Okay, so they give electrons. So due to this electron, bioelectricity we could generate. Okay, in very simple terms, I'm just giving you idea. So but the problem here is that, like scaling up is the problem right now. This is in the very I mean, like research is going on. It's more than 45 years people are working on it. So still people are having that scaling up is the very challenging actually. It's a question mark actually. So many people are working on it, and it's successful also. It generated in our lab also, we are working on it, MFC, and the results are quite impressive. But still the thing is that scaling up is the one question marks we have. But here also the interesting part is that it treat the water as well as it generate the energy. So this is the simultaneous things we can achieve from this technology. Then advanced oxidations. Advanced oxidations process is also, I mean, like currently many researchers are working on it. So the thing is that, like here, the interesting part is that, like some of the organic, like a very strong organic citrans or organic, yeah, inorganic pollutants. Okay, it is difficult to break actually. So we are using here sunlight actually, UV, ultraviolet. Okay, so it activates, what happens is that peroxide. Okay, then hydroxyl peroxide. Then when it activate, then what will happen? Then it acts as one of the the reactive agent, actually oxidizing agents, we should say, hydroxyl radicals. So it breaks down the organic compounds which are highly bond, actually. Then it is usually used in the pharmaceuticals, yeah, pesticide, dyes industries and all. The people are using it. It's a the result is quite satisfactory, and the sustainable gained, I should say, that the pollutant destructions without toxic byproducts. That is what sustainability in point of view we can get. And right now, of course, people are still working on it, biomass adsorptions and all, bioabsorptions. So people are working on different type of biomass. Activated carbon derived from biomass, different type of industrial, not industrial waste, agriculture waste they are using. And successfully, maybe people are working on mostly in dyes, organics, yeah, heavy metals removals, yeah, adsorptions. They're working on it. But the thing is that the efficiency is not that very high. Okay, you can use, but efficiency is not high. So that to make it more improve the quality of efficiency, many people are using some chemical, so that it can impregnate the chemicals, or yeah, immobilization with some bacteria and all, so that it can create more active size, so that adsorptions could take place higher. So this kind of research also going on, but it's not very new, but it's a kind of sustainability, a part of sustainability, but we can utilize. Then another thing is then anaerobic treatment. In this anaerobic treatment, as we all know, that it is more about bioenergy generations. So biogas generation is there. So from biogas, this anaerobic treatment, we can get heat as well as electricity generation. So here in sustainably gained, what we get is that energy productions and sludge generation is quite less. And algae is also another, people are working on it. So in this algae treatments in California and the places the country where there is a big oceans and all, so they're utilizing, like in Japan and all, they're utilizing the culture of harvesting of this kind of algae, the biomass, so that they can produce biofuels such as biodiesels and all. So this is quite interesting that in India also, some in lab skills people are started working on it. So the success rate is quite good. So carbon captures, and those people who are interested with carbon capture and all, you can try this out, and it can give you a good results. And especially those people are working on biomass also, in the sense biofuel and bioenergy related. And also you can work on it, you can try for this. Then constructed wetland. Now almost the researchers are environment, especially in wastewater treatment, especially in industries, also in the lab scale also, we are working on a constructed wetland, actually. So this is very cost effective, actually, and the result is quite impressive. So that it is the mimic of the natural, actually nature water treatment, I should say. Then this is how why we say it's sustainable, because it's used the vegetations, the plant and all, and it's a soil, you're not disturbing any environment, actually, here. So the process is more about the filtrations here. Okay, the BOD COD removal is there, and you can achieve good amount of BOD COD removal and all. I have seen that some of the students, they have in my department also, students are working on these things, and they could achieve a very good BOD and COD removal. Then here you don't need anything as such like electricity. All right, so you can plant but the thing is that it is very very I should say that very similar with phytoremediations. So many people used to confuse about this phytoremediations. Of course, this is one phenomenon of phytoremediation. Okay, so this is some of you who are interested in the wastewater treatment, you can try this out also. This is really good, and it can also give you a high impact. Then hybrid systems. So hybrid systems is upgradation, I should say, it's upgradations of constructed wetland. So here what we are using is the phenomena of MFC. Okay, so as we know that like in the soil there are so many microorganisms are there that these microorganisms, they are the triggers actually, they are the main, they're like electrons. Okay, so they generate electrons, so you can utilize some of the substrates, okay, as a anode then cathode, then you can generate not only wastewater treatment, you can generate energy also. So here many people are working on this, so I find it that this is also one of the sustainable and one of the green technology that we can implement in industry as well as in the sewage plant also we can apply. I think India has lots of land actually, so we can apply this kind of technology so that like it can little bit help rather than going for very high sophisticated equipments with very high price. And moreover, and one another interesting part is that like pond treatment actually, so what we call is a waste stabilization pond. Now it is also implemented in India, like I'm just giving you some in Brazil also they are implementing successfully. Moreover, in Haryana, Swachh Bharat Mission's Gramin, therefore implemented and it was successfully carried out. And here it is very similar. There are three stages are there. Anaerobic, first step is anaerobic pond. Then after that, facultative ponds. Then after that, maturation pond. So in Kolkata, if you see that like people are using like a fish pond actually, okay, fish farming they're doing. So what they are doing is that like first, the wastewater in the primary stage, the wastewater it settles down, then it moves to the next. It is something like in clarifier. In a clarifier, slowly it moves and it got settles down. So it is something like here the wastewater got settled down. Then some of the plants and all, when the water hygiene and all it grows there, and they can use as a fish farming and all. So I mean like this is this kind of, I mean like we have numerous number of land ponds, so why can't we use as a this as a waste sustainability, I mean like technology for wastewater treatment. So let me summarize that like a green and sustainable wastewater. Like if you summarize that the key strength and sustainability, if you just go through, then you can find that like all the technologies has their key strengths, different key strengths, and what kind of technology is good, that is the question mark actually. Okay, it depends on that like what kind of wastewater you want to treat and what kind of technology you want to use. It's depend on the industry also. Okay, so like of course this kind of technology, if we can implement in many wastewater treatment and plants and all, so I hope that like India can grow and we can go in the directions of green and sustainability. The benefits of wastewater treatment for sustainable development. Okay, if you see in the environmental perspective, like ecosystems protections, water reuse, soil protections, and all these things are the environmental benefits. Then social and economic benefits also, if you see, then community health, of course, it is very important. Then like not only it will have impact on the environment, but it once the environment is good, like the earlier lecture, the safety and all, I always say that like everything is connected actually. Environment, safety, and health, all these things are connected actually. If the system is not safe, it will impact on environment, then it will impact on the health. So these three, safety, health, and environment, this is very important actually. So if the water is not safe, it will impact on the environment as well as it will impact on the health. So this is very important. Then safety, water access, and employment generations, cost saving, economic growth, all these things are very essential, so that we should focus on sustainable development. And what are these SDG? Okay, so SDG is Nation Sustainable Development Goals, and there are certain of category we have. Okay, what are the components of it? Here, like clean water and sanitations, good health and well-being, sustainable cities and communities, responsibility, consumptions and productions, climate actions, affordable and clean energy, industry, innovations, and infrastructures. So these are some of the part of the components actually. So SDGs are focusing as a holistic, I should say. Okay, so it is more about how to live environmental free culture, free world. This is what actually. So this is more about our well-being actually. So it is very very important. Like each one of us should think in the directions that like what I can contribute. Okay, not like the researcher will do alone, but in the house we can see not only in the urban, in rural area, everywhere. Okay, so cleanliness, all these things, how the treatment of wastewater, we should have this kind of mentality that like everyone is involved. Okay, so that we can fight for this sustainability. So not only in wastewater, of course, air pollutions also, and solid waste also. So all these things is collectively I'm saying that like this is very very important, we need to focus on it, right? So when we talk about wastewater treatments, not only clean water or sanitation, all right, so we should think in the higher version, I should say. Like nowadays people talks about climate change and all. Climate change not only impact on our global warming and all, right? So we need to have this culture that like wastewater treatment, not only wastewater treatment, we need to focus on that like uh, how things energy we can recover, then how we can implement in such a way that like we can reduce this waste, actually wastage of water conservations and all those things. Okay, they are hand to hands, we have to work in the sense like as I said like in the starting of these our presentations, wastewater is started from our household only. Okay, how much water you have wasted, how much water you have polluted. So if every household, okay, if we reduce, then how much it will give to the impact, that is very very important. uh Now I would like to take you to the journey to our lab. Okay, the sustainability, the greenery. Now we have overview about the ideas about now you have seen. Then now what exactly like in it is very generic things we talks about, right? But in our lab, what kind of technology we use and what kind of like research we are doing, that I just want to highlight you so that like it will be easy for you to understand. Okay, then not only just bluffing and saying that if you can see the work what we are doing, and then it will give us more impact, of course, that like what could be the more efficient things we can do in our own lab, right? So I know that most of you are researchers, and also I hope that like you can correlate with me. There was a project, it is completed in 2022. So here we have proposed that electrochemical membrane bioreactor, and this is a treatment of municipal wastewater and simultaneous generation of bioelectricity. So it is the concept is more about MFC, which we talked earlier. So we have published 4 paper in this project, and 2 patents were granted, and TRL technology readiness levels 4 up to 4 we walk out, and it was well received. And first we designed, and it was collaborated with the IIT Kanpur and all, we are working on it. Then POC, the prototypes we have designed first, we optimize it, then we scale up, then we fabricated EMBR, that is electrochemical membrane bioreactor. Then in lab scales, this is our workstation is showing here. And we could achieve very interestingly, like we have taken 4 sample for STP plant in Prayagraj. Then we could achieve like POC, and when we compare with the fabricated EMBR, we could achieve 0.042 milliampere. So you may be thinking that this is very minute actually. Of course, I'm saying that like most of MFC, still now the challenging thing is still like how to scale up actually. That's what I told you before. So scaling up is very, very important. And in this reactor, we could remove COD as well as BOD also. And it is not that very, how to say, effective, but still it could reduce like 40 to 50% of BOD and COD. So I mean, like, it's quite impressive. The next thing is that we are working on contaminated water. Okay, like simulated wastewater, we are designed like textile industry. Yeah, we are talking about some industry, tannery industries and all. So dye removals like decolorations of dye by using like nanoparticles, okay, like the particles derived from the leaves and all. So like it's a more process about the adsorptions process. So here also, I mean, like impressively, we could uh, uh, around 80%, 80, 85, 80 to 85% we could remove the uh, dye, decolorizations of dye. But the thing is that like, the percentage is, the initial concentration is quite low, in the sense like 100 ppm we are working on it. But the challenging part is that like if more concentrations, then what kind of improvement we can do. That is also another challenging part, whether we have to modify the structures of the absorbent, whether we have to immobilize, we have to impregnate. So these are the questions that we are working on it right now. And electrocoagulations, of course, it is also very effective. And but the thing is that we consume energy. So that's why the more you consume energy, you can get purifications, more purifications. So this is also another challenging part. And we are working on the arsenic also. As we know that in the Sharla, Sharla is one of the reputed, actually, it's shortlisted like hazardous element. So arsenic comes number one. Okay. So we are interested like if we are trying to remove these heavy metals and all, then we are trying for others like zinc, copper also we try, and chromium also we try. And here I'm just highlighting that like arsenic is also one of the poisonous, and it is very very crucial that like if you talk about West Bengal side, if you talk about a Bihar side, there arsenic impact is there. So some of the samples we have collected from there, and we are just trying to use our technology, then how we can remove. So the impressive results we got, as I said, like bioabsorbents, we have collected different type of bioabsorbents like agriculture waste, kitchen waste, all those things we have collected, and we process it in our lab. Then you can see the results that like it's quite impressive, that like around 80, okay, 70-80% of arsenic we could remove, because we cannot expect very high, actually. All right, like we cannot expect like 90%, 80%, and 99%. If we are using a technologies like electrocoagulation, of course we could have get lots of, I mean, like a very high efficient. But here impressive removal we could achieve. Moreover, we would try for immobilizations also, bacteria that could enhance the removal capacity. Here also we have published a few paper, and a patent also we have filed, and two were granted. And coagulation process also we have conducted. Then here impressively, if you can see that ferric chloride and copper sulfate we are using, then you can see that like in arsenic in India, it is allowed for drinking purpose. It should be below 50 ppb. But World Health Organizations, it says that like it should be below 10. Then we could achieve after 60 to 80. Okay, so I should say around 60 operating minutes. So we could achieve by using our ferric chloride. But here the initial concentration, you may be wondering what could be the initial concentrations. Of course, initial concentrations for arsenic is we have taken very less, 1 milligram, 1 ppm. Okay, because for this project I have collected a sample from Meghalaya. So in the Meghalaya, I mean, like there are border with the Bangladesh, actually. So from there, I mean, like when I approached the pollution control board, they said that there's no arsenic problem there. But I went to the Jantia Hills because they have a coal mine and all. So I have collected some of the sample. Then it comes around 500 ppb. Okay, around 500 ppb. Then based on that, we work on the real water as well as simulated wastewater also. Then we could get a very good, impressive result. Then electrocoagulations also we use. Then we could remove, as I said, the 99%. But the thing is that like here, whether it is efficient or not, because we're using electricity. Okay, so we could after optimizations and all, we could receive 99% of removal. Okay, these are some of the glands that like characterizations we have taking place. And if you can see that like the electrode what we're using is the iron electrode. Okay, so We could have used some other electrode also, but it's a research that like we are trying that like alternate, like iron and copper and aluminum like that and all. So, but we find that iron is a very efficient for that. And perturbation curve, if you see that like pH play a very vital role. So this is our result. Moreover, we work on the plant also actually. So many of you may think that is it a phytoremediations? Exactly, this is not a phytoremediations. It is a toxicity test, I should say. Okay, why we have chosen wheat plant? Actually, if you see the like Bihar and Punjab and those area, they are wheat belt area actually. If you come to northeast and West Bengal, that is rice belt area. So in wheat belt area, I read one article that in Punjab, in the wheat, okay, in the wheat, in the grain, there were arsenic contaminations was there. So that triggers me actually. So this is why we started working in the hydroponics. Okay, in the hydroponics culture, we from the seeds, okay, from the seeds we germinate and we put in the hydroponics. Then the wheat were grown, and we always compare with the control. Okay, so you can see that like physically analysis was also carried out, and microscopic image also, loaded, control, and uncontrolled. If you see these two, you can see that like how things are distorted, okay, when it contaminated with arsenic. So not only in hydroponics, we work in the plant, like in the flower pot, we have planted different type of crops, for example palak hai, spinach. So all those kind of we plant, we try. Then after a few months, 2-3 months, we can find out that like impressive results we got. Like physically we can see that this carrot, okay, the control ones looks very healthy. Then the arsenic contaminated, the exposure with arsenic one, if you see that like it is very thin actually. So this kind of studies we are carried out. Even the seeds also, in the wheat seed, the quantities are very less. Okay, so this kind of, I mean, like studies we have carried out. So I hope that like if you can dig in more, okay, like with other plant and all, what we are consuming right now, okay, the in the vendor vegetable shops and all, if you go, are you really sure that like all the vegetables what we are eating right now is safe or not? So there is no, I mean, like fasai or anything, I mean, like standard, anything inspector, they are going there and inspect whether the plant is really safe to eat or not. So I mean, like this is a high time that like sometimes what I feel that like sometimes randomly we should check also, right? Like what kind of fertilizer they're using, like pesticide and all. So it may triggers that like I mean, like many people have hair loss. We are having so many cases, gray hairs we have, so skin's problems we have. So I think what we are consuming right now, so I mean, like it's a high time now that like we should think over it. These are some of the projects we are working on it. Some of them are already undertaken, and right now few more projects yet to come. So I'm just giving you some ideas so that like you can also, if you're interested, then we can in future also we can collaborate and we can work together. And these are some of the consultancy like Pollution Control Board Delhi. Like usually we go to collect a sample and we analyze. Mostly it's more into with tannery and textile and all. And these are some of our IP here. So national, international, these are the granted patents, and few patents we have filed already. And some of the collaborative work like Eastern Botanics is a very new, I mean, like they are startup, okay. And Canopy, there's IT students, I mean, like IT Kanpur students, they have done the startup, and also we are working together with them and all. So right now they're based in Bangalore. And these are some of the ongoing, like just a broad actually, just showcase that like what kind of research we're doing. And now we move on to the some other research area like medicinal plant and all that also we are trying. Like before concluding, I just want to say that like there are many controversial, skeptical thinking are there. Like is it really feasible or not? I mean, like this technology and all. Okay, that's why I'm saying that like people are working hard actually, like technology advancement research. what we expect, we are expecting that they can deliver more efficient and cost-effective solutions. Okay, so like a way forward, actually, this is not the end. This is just in progress. Actually, I should say it is in progress. Sustainable wastewater treatment is already in practice. Also, it's still research is going on and is in progress, actually. Okay, and ensure the healthy and of course the sustainable work. Then the most important thing what I want to highlight is that collaborations. Okay, collaboration, knowledge sharing. Okay, right now what we are discussions right now is also like collaborations and knowledge sharing. Of course, like I can learn from you, you can learn from me. So something like this kind of, I mean, like understanding should be there, so that institutions, organizations to organizations, if we can work together and if we can promote global sustainable development in the field of wastewater treatment, of course, by 2047, I'm hoping that like a Viksit Bharat 100% hoga. So Viksit Bharat, I mean, like not only focusing on our these things like self-reliance, we should also focus on our sustainability as we discussed already, and technology advancement bhi hai, and environmental protections and improvement quality of life for all citizens. So what I feel is that like all of us, me, you, everyone is, I mean, like we need to contribute actually. Okay, ऐसा नहीं कि हम बात करते, we talks a lot and after that we are not doing anything. Because for me to, I mean, like rather than talking, like I prefer to action. Okay, walk. So many people, I mean, like researchers I have seen come across that they work so hard. Okay, and they achieve also. All right. So lastly, what I want to share is that like as one of my idol, I should say that Dr. APJ Abdul Kalam, he said that like great teachers emanate out in knowledge and patience and compassion. Of course, whatever you know, whatever you have, please share it to other. Okay, like it will be resourceful for other people. You may think that you are nothing, but it will be helpful for somebody. And whatever we should propagate, we should share to other. So this is how we gonna grow together actually. So with this note, I want to wind up my presentations. Okay, so I don't know whether you have received it or not. Hello, ma'am.
Yes, sir. Thank you, sir.
Whether I bore to you or not.
No, sir. It is a very informative session. Participants, if you have any query, you can ask now.
Yeah.
Sir, am I audible?
Yes, Anand sir. Yes.
Sir, I just seen that you have worked on the arsenic removal and color removal by
Yes,
the
sir.
process of adsorption and the electrocoagulation.
Yes, sir. Yes, sir.
How do you see these techniques to be commercialized? Like, because whatever the work you have represented is I think on a lab scale.
Correct,
And
correct, sir.
getting good results like 80 to 90% removal of these contaminants, like you talk about the arsenic or the color removal. So how do you see these research work in terms of commercialization, or what kind of problems we can face on that actually?
Sir, see, large scale is a very tricky thing, sir. I mean, like the efficiency what we get in the lab scale, when we scale up, so we cannot get that much. I mean, like we have to optimize and all. We cannot get that much efficiency actually. That's one challenging part. Yeah, of course, industries and all. Like when we went to Tenerife, they have started implementing this electrocoagulation process. I have seen. So they are quite happy that like. Not in a commercialized, but they are adopting actually slowly they are adopting. So I mean, like it is a good things that like electrocoagulations also people are working on it. So of course research is going on, like what kind of electrode we should use and all. So regarding about that is the dye removal. Regarding about this arsenic, it is quite challenging that like arsenic, when we talk about arsenic 5 and 3 is there. Okay, so arsenic 3 is more toxic actually. So
Yes.
speciation is another important thing, because when we talk about I remove 100% arsenic, that you may be removing only arsenic 5, not 3. Okay, so that is the very challenging, because most of the researchers, they don't know that like they don't do speciation actually. Okay, you might have removed 80% and arsenic 3 only 10% you have removed. So this is also very challenging actually. So adsorptions like of course, I mean, like filtrations people are using nowadays in the RO at home. Also, you're using activated carbon and all. Of course, people are using, and it received well also. But the thing is that, like, is it sustainable or not? Because we have to change all the time, you know. So what kind of, I mean, like sustainable? Because once you clean it, like deabsorptions when you do, then it will go back to the, you know, groundwater. So that things also we have studied. So we comes up with some encapsulation, like absorbent after it exhausts, all the absorbent when it exhausts. So we do the encapsulation like cementing and all. So we can make with the fly ash and all, we mix together and we can make a blocks and all. So those kind of research also we are working with the civil department and all. So I mean, like, it's coming out good. So sir, I mean, like, commercialize what when you talks about, of course, in the market people are working on it, but still we are trying that, like what could be the more efficient way we can use. So so I mean, like sir, you may be doing some research on it, I think.
Sir, actually, I'm an environmental auditor and I used to visit so many different industries. Basically,
Oh,
I'm
that's
based in
wonderful,
Gujarat.
sir. Okay.
So that's why so many times it happens that when we come across with the industry people or we talk with them, so they are
Right.
facing such kind of problems like different contaminants which are generated in their wastewater.
Mm-hmm.
So that's why they. So since I belongs to the like academics, so they asked me to do some kind of research work on these, and if you can provide us the solution for these kind of problems. So that's why I just asked you about these things, sir.
Yes, yes, yes. I can understand, sir. I can understand because earlier I was also working as a safety auditor in industry. So I was specialization in industrial safety actually. Then I moved to environment. So I mean, like, it is hand on hand, and so I'm very happy that, like, in the future also we can collaborate together and also. I mean, like, I really appreciate that the question. It is very genuine actually. In industry also, when we visit, they ask the same question. So even they ask to send some student and all. So of course the student they go there and all, but sometimes, you know, I mean, like, this kind of problems happen actually. We cannot meet their requirement actually.
Yes, yes, yes.
Hmm.
Okay, sir. Thank you, sir. Very much informative and really.
Thank you so much, sir. I mean, like, I really appreciate the question you asked. Yeah, it's a nice interaction with you, sir.
So if you can, sir, share your email ID or any contact, so
Yes, sir. Yes, sir.
we
100%,
can be
sir.
in touch with. Huh?
Yes, yes, yes. It's with Susma ma'am also. Hana. So
Yes, yes.
yeah, yeah, yeah. I'll collect your email ID and all to ma'am so that, like, and we can interact further. Not in this platform, in other platform also we
Yes,
can meet.
yes, sir, definitely, sir.
Right, right, right.
Okay. Okay.
Yes. Any other question?
Good evening, sir.
Yes. Sanjay, is it?
Sir, you have talked about phytotoxicity.
Yes.
So, under that, you have quoted the word called
Hydroponics. Yeah.
hydrophobic. Yes, yes, yes,
Yes.
sir. So, while germinating the seeds, whether you have directly opted in hydroponic method or you have germinated in other ways, sir?
Ma'am, actually, what happened is that, like, first we have to start from the germinations because many people they started planting the plant. Okay, I mean, like, it may be grow or not, but it is very difficult to study actually for study purpose. Okay, so from the germinations, okay, when it germinates, then from there we started giving the exposure of arsenic, yeah, any heavy metals, what you want to study. Okay, so that is the proper way actually. If you're doing hydroponic study, then you have to one control you have to have. Then another thing is that, like, from the germinations you should give an exposures of it so that it will grow. Okay, you're getting my point. I don't know.
Yes, sir. Yes, sir.
Yeah.
Sir, as sir quoted,
Hmm.
arsenics and all can be removed from either water or a wastewater. With the existing filter medias, whether we can improve the removal efficiency of such arsenic or some uranium or some any other radioactive metals, is there any adsorbent which can add up to the existing filters so that it can even remove all such
Yeah,
RA
ma'am.
method. Yeah.
Yes. That's very interesting because arsenic, if you use only biomass, it will not help. So because it's a negative charge, right? You need a positive. So metals like if you can use some iron or impregnate with some iron and all those things, so it can enhance, actually it will improve, enhance the absorbent. So in this case you can uh, uh, absorb more arsenic, actually. Okay, so this is very tricky, that like whether it's 100% we can remove arsenic. Yeah, the answer is that yeah, we can remove the things that if you use electrocoagulation process and all, but absorptions is little bit what I'm also a little bit skeptical about it. The things that like of course West Bengal, Bangladesh, people are using different type of filtrations and all. Now people are using ultrafiltration and all those things, but they think that like they achieve. Okay, but the thing is that there is a little bit question mark, because if you talks about the threshold limit of it. Okay, so US EPA or yeah, World Health Organizations is a 10 ppb. To bring to lower down till 10 pp level, it is very, I mean, like a difficult situation, actually. So like if the concentration is less, for example, like as I said, like I have collected water sample from Meghalaya, so that is what's 500 ppb. Okay, so it is very easy. But in industry, okay, like metallurgical industries and all, they generate arsenic. Copper industry, they have it generate because it is associated with metals, actually. So yeah, acid runoff, so their arsenic contamination is very high, actually. So for there, I mean, like you need to rigorously, you need to use different type of like hybrid system, I should say. Like nowadays we are working on a hybrid system also, because one technology is not sufficient, you know. Like in RO also you have seen absorptions happen, disinfection is there, ultra violet is there. So like that, I mean, like you need to have if you can have a chain of yeah hybrid system, if you can have, yeah, of course I can think that like I think you can achieve zero arsenic.
Okay. Okay, sir. Thank you. Thank you, sir.
Thank you, ma'am. Thank you.
Sir, I have one question.
Yes, sir.
Regarding the microbial fuel cell,
Yes,
uh,
sir.
is the for wastewater treatment, how to improve that one? Because we are using in the lab, but that is not effective one.
Sir, I mean, like, did you give any nutrient? Sir, your voice is cracking, sir.
So my question is that related to the microbial fuel cell to
Correct.
treat the wastewater,
Right,
industrial
right.
wastewater. But we are doing that one, but it is not effective that much. How to improve that?
Sir, this is also very, I mean, like, we are venturing now because we are use some catalyst also and doping also in the electron. But if you see that very high efficiency, sir, like whether your focus is generations of electricity, yeah, removal of wastewater. So this is a very true tricky things, actually. Of course, simultaneously you remove it, but the thing is that like mostly microfuel cell people are more focused on the recovery of energy, actually, so rather than wastewater treatment. If you are trying to improve the wastewater treatment, then you have to, as I said, like Madam was asking, they're like a hybrid system in the sense like whether you can implement some secondary, yeah, in the next chamber you can use some filtrations, then it could give you, I mean, like wastewater treatment will be much higher. Because I was also trying, actually, but the thing is that like electricity generation, okay, first things, then the second thing is that like a wastewater treatment. So these two is very, I mean, like you cannot get a very high efficiency, actually. So my suggestion is that like if you can inculcate, yeah, if you can you know, a bit like a hybrid system, if you use some membrane system, yeah, some filtration, okay, so that can help the water treatment. Okay, and regarding about the efficiency, as I said, like what type of bacteria you're using, I mean, like what kind of bacteria involving, that's also matter. Then another thing is like a nutrients. Okay, we tried actually nitrogens we parse in, but I could not find it. It is very much efficient. Like many people are giving some catalyst also, some nutrient also to the microbes. But it takes time, sir. It is very slow, and the scaling up is the main problem in the MFC. Okay, So I mean, like
Yes,
research
sir.
is going on, sir. I
Scaling
mean,
is the
I cannot give you
main
the
problem.
exact, yeah, the exact answer I cannot
Yes.
give you actually. Yeah, it's going on, sir. Actually, है ना? Research.
Yeah.
Sir, you're working on which industrial waste?
No, sir, I'm not working in industry. I'm as an associate professor in Marwari University.
All right, all right. Your student may be working, maybe.
Yes, yes.
Okay, okay. So
Just
in what
now
type
we
of?
have started the last semester only for this new topic for myself.
All right, sir. If you can try domestic wastewater, no, I think it will
Okay.
be better. Like I'm working with a municipal
Okay.
wastewater. So if you try domestic
Okay.
wastewater, it will be give you because so many microbes are there actually.
Yeah. Yeah. So what type of the catalyst you're talking about, that?
The catalyst in a sense like doping. Okay, I mean catalyst is something like it can give more. I mean nutrients to that. Okay, so
Okay. Okay. Okay.
yeah.
Okay. Thank you, sir. Is
Thank
it
you.
possible to get your PPTs? That is some of the more informative information is given in your PPT. Is it possible to get?
Sir, I mean like I can share. I give it to ma'am. Then
Yes. Yes.
yeah, you can collect from ma'am. Yeah.
Sure.
Yes, sir.
Sure. Sure. Okay. Thank you.
In futures, we can, as I say, Anand sir, we can also join hands. We can walk, sir.
Sure. Sure.
Sure,
We
sure,
would like
sir.
to join. We would like to work with you also.
Right, right, sir. I mean, like if you're working with these things, no, I mean, like microbial fuel cell, you'll be needing a workstation.
Yes, sir. Yes, sir.
So workstations, like as I said, that canopy. Okay, these solutions right now, they are making a workstations. Actually, they manufacture.
Okay. Okay.
Okay. So if you want to buy, also, I mean, like I can contact with them also.
For a small range of the potential state, I have that one in my lab.
Okay, which company is that?
Like from the IIT Kanpur, sorry, from IIT Kanpur, one of the canopy.
Yes, yes, yes. They are my friend only, sir.
Yeah, yeah.
Oh,
I bought it. I bought last semester itself.
okay, 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 okay. So
Okay.
in a future project, you can go for Metro and all. There is a good one, and we are
Sure,
using
sure.
CH also. We are using right now. Yes.
Okay, CH instrument, right? Yeah. Okay. Sure, sure.
Yes,
Thank,
yes, yes.
thank you very much.
So I'll be delighted. Like if you can come down to our lab, also you can see. है ना?
Sure, sure, sure. Definitely.
Please do visit to Sangam also.
Sure. Okay.
Yeah.
Sure. Okay, sir. Thank you very much.
Same here, sir.
So, any other questions? Participants? If you have any question or query, you can ask now. I think sir explained the topic very well. It is very informative session, sir.
Thank you so much, ma'am. I don't know whether everyone can receive or not. If not, one last word I want to say that like, see, I speak very fast and all. Sometimes people don't get also. So please, you can connect me through my mail ID. You can collect from ma'am and my number is there. So anytime, and if you happen to visit MNIT, yeah, Prayagraj also, please do let me know. Okay. So I'll be very pleased to have you. And
Yes,
thank you so much, ma'am. I mean, like, I delighted. I mean, like the platform what you're using. I mean, like this is just for me. It's a starting, not I mean, this relation is just starting only. In future, also
yes,
we can grow.
yes,
You know?
definitely, sir.
And
Yes.
the last things, I want to greet you all. Merry Christmas in advance.
Thank you very much, sir. So here, if we conclude today's session, on behalf of the organizing committee, I sincerely thank you, sir, Dr. Suantak Kamsonlian, for his insightful session on wastewater treatment and sustainable green technologies. Sir has effectively explained green and sustainable wastewater treatment approaches, including advanced oxidation process, sustainable adsorption techniques, and anaerobic treatment methods. He also highlighted the importance and benefits of wastewater treatment for sustainable development. Additionally, he shared some project carried out in his lab, which greatly enhanced the knowledge of all the participants. We are grateful to Sir for sharing his valuable expertise and time, making this session highly informative and impactful. Thank you. Thank you very much, sir.
Thank you, ma'am. Namaste, ma'am. Thank you so much. Yeah.
Thank you, sir. Now I request all the participants to be in the meeting as our valedictory function is just started now. Welcome, Registrar sir. Welcome.
Thank you, madam. Am I audible?
Yes, sir, you are audible.
Okay. Shall I start?
Just a minute, sir.
Yeah.
So, a very good evening to all. On behalf of the organizing committee, I warmly welcome all the dignitaries, resource persons, faculty members, and participants to the valedictory function of the Faculty Development Program. Over the past few days, this FDP has provided valuable insights, practical knowledge, and meaningful academic discussions. As we conclude, we take a moment to acknowledge the efforts, learning outcomes, and contributions of all involved. Today, we are truly honored to have our chief guest, Dr. Vipul Shastri sir, Provost of Vidyadeep University, and guest of honor, Dr. Vilin Parekh sir, Registrar and Dean of Faculty of Engineering and Technology, Vidyadeep University, with us. On behalf of organizing team, I welcome you both on this valedictory function, sir.
Thank you, madam.
It is my privilege to introduce our esteemed chief guest, Dr. Vipul Shastri sir, the Provost of Vidyadeep University. Dr. Shastri is a respected academician, a visionary administrator who has made significant contributions of higher education. As provost, he plays a key role in strengthening academic excellence, quality assurance, and student-centric initiatives at Vidyadeep University. His leadership, experience, and commitment to educational values continue to inspire both faculties as well as students. We are truly honored to have Dr. Vipul Shastri sir with us today, and we warmly welcome him to this program. Now, I kindly request sir to please say a few words and address the gathering. Thank you.
Thank you, madam. Am I audible?
Yes, sir.
So in today's FDP program, Registrar Dr. Vilin Parekh ji, Coordinator Dr. Chaitanya ji, Co-Coordinator Dr. Susma ji, esteemed resource person, members of the organizing committee, and dear participants. It's a great pleasure that this chance has been given to Vidyadeep University in AICT Training and Learning Academy FDP, that is the Atal FDP. The main vision of is to empower the faculty to achieve goals of higher education such as access, equity, and quality. And when such topic which was there, which is on emerging trends and research frontiers in chemical engineering for green and sustainable future. By this topic, I think that faculty, they will be able to know regarding the recent trends also. And here also, there are so many good topics which was there regarding the water audit, which was there regarding the today's topic, which was also very nice. So by this is the recent era which has been required regarding the environment, regarding the green energy. And even we are seeing right now in so many cities of the Indias also that where some difficulty which has been there, and due to that pollution and also thing that has been increasing. So in that, faculty has very important role, as we are always saying, the academia industry linkage which has to be there. So in with this linkage, we can do so many things. We can go for the research also. Even we can give the awareness also, which is one of the most important part of the academician also. So I must say that chemical engineering is no longer confined to traditional process design and production efficiency. Today, it plays a strategic role in national development, addressing concerns related to energy efficiency, water conservation, waste minimization, clean technologies, and sustainable industrial growth. And the theme and session of this FDP were therefore not only relevant but also essential in preparing faculty members to meet the expectation of modern academia and industry. I am very much thankful to all the resource persons who have imparted the knowledge to faculty members, due to which they will be able to now train the students also. This is the most important aspect of the faculty development program, that after taking the training from this FDP, then you have to impart it to your other colleagues as well as to the students. By that only we will be able to spread knowledge more and more. I must comment that distinguished resource person for sharing their expertise, research insight, and industrial perspective with great clarity and depth. Their contribution has surely broadened the participants' understanding and inspired new direction in teaching methodologies, applied research, and industrial collaboration, which is a requirements of today's era. My special appreciation to organizing team of Vidyadip University. Since 6 days, they are giving their valuable time from 6 to 9, 6 p.m. to 9 p.m. and they are connecting with the AICT, and by this only we will be able to achieve the objectives and quality benchmarks. So many congratulations to the Dean of the Engineering Faculty, Dr. Vilinji, Dr. Chaitanya ji, Dr. Susma ji, and all the team of Vidyadip Institute of Engineering. And thank you very much to AICT for giving opportunity to Vidyadip University. Thank you very much.
Thank you, sir, for your
Thank you, sir.
valuable.
Thank you, sir.
Now, it is my privilege to introduce our esteemed guest of honor, Dr. Vilin Parikh, sir, who serve as the Registrar of Vidyadip University and Dean of Faculty of Engineering and Technology. As a registrar, Dr. Parikh, sir, plays a key role in academic administration, institutional governance, and policy implementations. As a Dean of Faculty of Engineering and Technology, he actively promotes academic excellence, quality teaching, research, and faculty development. We are honored to have Dr. Vilin Parikh, sir, with us for this FDP and extend a warm welcome to him. Now, I kindly request, sir, to please say a few words and address the gathering. Thank you.
Thank you, madam.
Thank you, sir.
Respected chief guest for today's function and our respected provost, Dr. Vipul Sastry, sir. Esteemed resource person from various universities and industries, organizing committee members, and all the participants from various institutes across the India. Good evening to everyone. Friends, as we come to the conclusion of this AICT Atal FDP on emerging trends and research frontiers in chemical engineering for green and sustainable future, it gives me immense pleasure to address you during this valedictory session. Over the past 6 days, this FDP has successfully created a vibrant academic platform for knowledge exchange, intellectual discussion, and professional enrichment. The carefully curated sessions covered a wide spectrum from green and sustainable chemical engineering practices, water conservation and audit, membrane technology, corrosion prevention, quality control and assurance, plant-based chemical extraction, analytical method validation to advanced process simulation and wastewater treatment. Each session reinforced the growing responsibility of chemical engineers in building a sustainable and resilient future. I sincerely appreciate the distinguished resource person who shared their expertise with clarity, depth, and practical insight. All the sessions were full of practical knowledge. Their contributions have undoubtedly enhanced the participants' understanding of both emerging research frontiers and real-world industrial challenges. I also commend the participants for their active involvement, thoughtful questions, and academic enthusiasm, which truly defined the success of this FDP. In today's rapidly evolving technological landscape, faculty members must continuously upgrade their knowledge to ensure that teaching, research, and innovation remain relevant and impactful. This FDP has served precisely that purpose, empowering the educators to integrate sustainability, quality, and innovation into curriculum delivery, research orientation, and student mentoring. I would like to place on record my appreciation for AICT Atal Academy for their continuous support to organize for such a grateful FDP. Also, I would like to appreciate the organizing committee, Dr. Chaitanya Singh and Dr. Sushma Gode Madam, and all the staff of the Vidyadeep Institute of Engineering and Technology, as well as Vidyadeep University, for making this FDP success. With these words, I congratulate all the participants on successful completion of this FDP and wish them continued success in their academic and professional journeys. Once again, my best wishes to Vidyadeep University and AICT Atal Academy for future academic initiatives, and my sincere thanks to everyone who contributed to making this program a success. Thank you all the participants. Thank you all.
Thank you very much, sir. Now
Thank
I
you, madam.
request, yes. Now I request participants to kindly share their views on this FDP. If anyone want to give feedback regarding the FDP, they can give on this platform. Yes, sir.
Hello, am I audible? Yeah, this is Dr.
Yes,
Anand
sir.
Matre. I'm working as an assistant professor in G.S. Patel Engineering College, Vallabh Vidyanagar, the CVM University.
Yes.
So I really appreciate, congratulate the Vidyadeep University for organizing such a relevant topic, or you can say it is a need of the hour, that green and sustainable future. And the array of topics which have been covered really means insightful and very helpful for me to understand the recent requirement in the industry, or what how we can proceed ahead with the sustainable approach. So once again, I thank you to Vidyadeep University. Congratulations to all the organizing committee for such a wonderful this FDP, that is a green and sustainable future. Thank you.
Thank you. Thank you very much, sir. Any
Thank you,
other
sir, for sharing your kind words.
participants who want to share their view? Yes, participants can give their feedback on this FDP. I request the participants to kindly turn on their camera so that we can take one screenshot. Just a minute. Thank you all. Now we conclude the session. So on behalf of organizing committee, I thanks to all I extend my sincere gratitude to everyone who has contributed to the successful conduct of this faculty development program. First and foremost, I express my heartfelt thanks to our Honorable President, Sir, Shri Jayantibai Patel, Sir, for the constant guidance, encouragement, and support provided throughout the planning and execution of this program. I also convey my sincere gratitude to our Honorable Vice President, Dr. Hiren Patel, sir, for the valuable support and motivation that inspired us to organize this FDP effectively. I would like to extend my deep sense of appreciation to our provost, and he is also chief guest for today's function, Dr. Vipul Shastri sir, for his visionary leadership and continuous encouragement, which played a vital role in the smooth conduct of this program. My sincere thanks to our registrar sir, who is a guest of honor for today, Dr. Willin Parekh sir, for his administrative support and guidance, and to and again, I want to thank our respected campus director, sir, Dr. Shri Mukund Bhai Patel, sir, for the constant cooperation and encouragement that extended to the organizing team. I extend my sincere thanks to all the resource person for their enlightening session and for sharing their expertise, which greatly enriched this FDP. My special thanks to the AICT Atal Academy for sponsoring this program and providing us with the opportunity to conduct such a meaningful academic initiative. I would also like to acknowledge the dedicated efforts of the organizing committee, coordinator Dr. Chaitanya Singh sir, technical team and support staff for their tireless efforts in ensuring the smooth conduct of this FDP in online mode. Finally, I thank all the participants for their active involvement, discipline, and enthusiasm, which made this FDP truly successful. Once again, thank you all for your support and cooperation. Thank you.
Ma'am, ask all the participants to start their test,
Yes, sir.
assessment test.
Participants on your Atal participants portal, the test link may be active. So you can now start with your test. Also, there will be the feedback link also. So kindly fill that feedback form also.
Hello, madam.
Yes, sir.
When we are opening this link, that Atal FDP portal,
Huh?
there is a pop-up window. It says that the questions have not been uploaded.
Actually, sir, it will be activated after the end of the FDP. So FDP is ended at 9 p.m.
Okay.
So after that, it is activated.
Okay.
Any other query? Thank you all. Fill the feedback also. And on Thank you all participants. If you don't, the session is over, so you can leave the meeting.